Yay! Learning and loving with Jacob Harkey, Mr. Harkey. When we're in class, it's Mr. Harkey.
That's me. That's right.
Hi, Jacob.
How are you?
Good to be back. I'm good. I've definitely been, I'm like excited to come to school. I'm like,
right.
oh, okay, yeah, I have my class at 5:55.
Love to
And
see that.
I'm not gonna lie, I definitely am eating right now in class, which is probably unacceptable, but I'm still gonna, I just know it's better if I am not hungry when I'm learning, because I will learn better that way.
You're good. I wouldn't necessarily always allow that with elementary school students, but that's
But
fine.
you will with this, right?
I'll allow it. No demerits.
Look at that calzone.
Wow.
Okay, that's enough. Okay, so
I love that you just told me right before we started you're going to be sneaking and you're not going to tell anybody.
I'm not sneaking and I'm not telling anybody. I'm going to be shoving a freaking calzone in my mouth while we're working. But I'm not going to tell anybody. Just going to sneak that in. Hi, Ganja. Yes. Hi, Angel. Oh my God, that pizza looks amazing. It's called a calzone. Okay, cool. Okay, so I'm ready when you are. Let me grab my little vitamin water, actually, because I have my little icy. And then I have my pizza and my notebooks. And you know what's funny? Earlier today, somebody was like making a joke, not a joke, but being like, okay, so Laura, what's 0.5? And I was like, I just started laughing because I'm like, oh, you watched my YouTube.
Nice.
I was like, half.
What is 0.5?
Half.
Good.
Yes. Half.
Love that.
Okay, good. So yeah, let me, get away, Fly. You are absolutely not invited to this party. Okay, good. So let me get my notebooks and let me grab my my vitamin water. But how are you, Jacob? How's everything?
I'm pretty good. I had a meeting yesterday. Today's been a pretty chill day. Just been watching King of the Hill, watching It's Always Sunny in Philadelphia.
Nice.
Enjoying summer break.
That's so cool. Look, here's the first bite, guys. Gotta dip it in the ranch. Oh my God, so good.
How is
Okay.
it?
It's like really good. Okay, let me pull this up.
Sounds good. Pulling up my
I'll be right back.
Sounds good. While she's coming back, just to let everybody know what I've got in mind, we had talked last time about starting each lesson with a little review of what we've gone over before. So I'm going to start with this problem that I'm coming up with. Express 3/47 as a decimal.
But I do know one thing, I'll keep on learning and loving.
Learning and
Hi,
loving
Peter.
you.
Hi, Jamie Castro. Yes, I am. Here, let me move this. See above us, it says GED graduation quest. So yes.
I love that. All right. So if you remember last time, we were talking about the idea of starting each of these sessions with a little review of some of what we've gone over in sessions past. Does that sound good?
Yes, sounds awesome.
All right. Can you see, did I write this big enough?
If not, I can just zoom in like this. Express 3/4
47 as a decimal is what we've got in there.
Ooh, wow, my brain has to charge up again. Okay. Um, did you tell me what express meant? What does it mean when it says express?
Like, how would 3 over 47 be represented as a decimal? Like, if we wanted to convert that from fraction form to decimal
yeah,
form, how would we do that?
divide.
Exactly.
Okay.
So, if we want to do long division here, what number is going to go on the inside of this bar?
47.
So actually, remember, if we're doing 3 divided by 47, that
The
means
inside of
that's
the
the
bar?
same thing as, yeah. So that'll be like the same as 47 into
No, but
3.
what did you mean when you said inside the bar?
Oh, meaning that if we express it like this, that 3
Oh,
right here.
the
Uh,
47, it it's you would swap it, right?
so if we swapped it, then we'd be doing 47 divided by 3, which would be greater than a whole number. But 3 over 47 is actually going to be a very small decimal. It's a little bit different than some of the values that we were working with last time because this is going to be less than zero point 0.1. It'll be 0.0 something. So, do you want to
Hmm.
start with a different one and then maybe come back to this one?
Yeah, did you just come up with this one randomly or
Yeah.
yeah, okay, I didn't know if it was like part of the chart or something.
No, but we can come back to this one. Although it would also be good practice to do 47 divided by 3. You want to just practice that and just start with before we talk about expressing as decimals, you want to just do another
Okay.
long
Sure.
division practice?
Yeah.
All right. 47 divided by 3. And actually, while we're talking about this, there was something that I wanted to explain that just might make some things make sense.
Hmm.
If it doesn't and you don't feel like it's helping as much, we don't need to get too hung up on it. But we talked about the different ways to express division problems the other day. So we can say 47 divided by 3 and express it like this. We can
Yes.
say 47 over 3, which is the same thing, also 47 divided by 3. And then we can express it as 3 into 47.
See,
One other way.
when you said um when you were earlier when you said where does the what number goes inside, that's what I was saying, 47 goes there. But were you saying the opposite, that it's actually 47, the 3 goes inside?
For previously, yeah, because what I had on the
Okay.
last page was, one sec, 3 over 47. Whereas now we're looking at 47 over 3. So I switched it.
Okay. Okay.
Both of them, they're going to yield different values, but I think they're both good to understand how to do because
Yeah.
and then the one other thing that I just wanted to go over really quick that might be helpful is that 47 divided by 3 is going to be the same thing as 47 times 1/3. So one other way that we can think of this same value would be 47 times 1/3. And one other thing, as multiplication, I just did the multiplication sign in exchange for the x. I just put this little dot. It's not the same as a decimal because a decimal would be on the bottom, like right next to the bottom of the number. When you have that slightly elevated dot, that can mean times. And then of course, the other symbol for times is x.
Oh, so the dot could be times.
The dot could be times too.
Thank you, Nora. I'm already giving up. I'm just kidding.
Nora's in there. Hey
This
there.
problem seems, she just came in. And thank you, love, Kanani, Kathy. Love you guys. Thank you so much. The support is important, I swear. Let me tell you, I could just be like, you know what, Jacob, should we just do this another time and then never do it? Easily. It can easily be done. Okay. So, okay. Sorry, my brain is I'm blaming it on my brain, but I'm just learning and I feel like a weakling. I feel like I'm weak in muscle and I can't absorb anything.
No, you're good. I just
So
think that
3,
something that might
I
help
think
you.
I'm confused. I'm a
Yeah,
little
yeah.
bit confused when you say 3 like I understand the concept 3 goes into 47 and then 47 like what am I trying to add? I feel like I'm getting frustrated internally and so I need to like address it because I feel not like secure about this. I feel like I don't understand, like if there was like when you say inside the box,
Mm-hmm.
I'm
I think I
wondering.
did make it a little bit confusing the way that I just worded it here, but no, I hear what you're saying. And we can
Fading
definitely talk
out.
through it.
Thank
There's
you. I hate fractions because they're confusing. Hang in there. You're doing great. Okay, thank you. Hi, Linda. Thank you, guys. This stuff is hard for everyone. You can do hard things. Okay. Okay,
that's right.
good.
You
Okay,
can.
good. Brain could do hard things. Okay, so here I go. So would it be wrong if I wrote like if I was taking a test, not to, I always think of the Scientology thing. Everybody's always going, running, doing a course to pass a test. And I'm not trying to pass a test here. I just want to make sure that I mean, I do want to pass a test, but I
Eventually,
want to make sure, that I'm like really on, I don't want to miss anything. And then later it becomes harder because I missed something basic right now. And I
Mhm.
don't know what is needing to know, like what's important and what is just kind of, oh, just put that in the back burner. So when you do the 3 into 47, how would I know how to write it out? How would I know to put the 3 first and the 47? Or if is that wrong? And you're saying no, originally you wanted me to do 47, into 3.
I think I might have made it extra confusing because I started by looking at 3 over 47, and now we're looking at 47 over 3. So that might be a complicating factor that we looked at both versions of a problem where we're actually looking at two different numbers, even though they look like the same number. But I guess what might help is if I just say we're working with x and y. If I'm looking at x divided by y, that would be the same as y into x. How many times does y go into x? That's the same thing as x divided by y. So when you're writing out a division problem in long division form, I don't know if you remember when we were going over the terminology the other day, but in a division problem, the number that's on top of the numerator, if it's being written as x over y, x is going to be our divisor, y would be our dividend.
So I'm asking, how would I know what number would they state that in a course or on a test or something, like what the dividend and what, or is it always the top? It's always that, but oh my God, maybe I should just continue listening. Sorry.
You're good. You're good. It depends on the problem. If there's a word problem, then sometimes you'll need to be able to think to figure out, okay, what are they asking and how are we going to solve this? If we're just working with the numbers, then I think that if you just remember the different ways that a division problem can be expressed, then you'll remember which number goes where. But if you're verbally saying a division problem, whether it's x divided by y or 47 divided by 3, whatever number you say first, 47 would go here in 47 divided by 3. Now, the thing that a lot of people do say, and when you say this, it can make it more confusing. So if you just don't want to think of it in these terms, that's fine. But 47 divided by 3 could also be verbally said as 3 into 47. Sometimes people, instead of saying what's 47 divided by 3, they'll say what's 3 into 47.
Okay.
So I'm not sure if that helped. Did that
Yeah,
help
a
a little
little
bit?
bit. Yeah.
Okay.
But like, I don't want to, like, if I'm doing a test, uh, I want to make sure, I guess I know that. Like, if they say, what is 3 into 40,
And I
3,
wouldn't
or
expect.
even how you said it, express 3 into 47. I want to know what that means. Like, okay, does this mean divide up 3 into 47? So I would get two different answers, right? obviously,
Well,
from
yeah, because the problem that we've written
47
down
is
on this
bigger.
page is different than the problem that was on the last page. So, I mean, one thing, and we're bouncing around a little bit here, but one thing that I think also would be just good to understand is that when you're looking at a fraction, if the number on top is larger than the number on bottom, then the number is going to be greater than 1. If the number on top is smaller than the number on bottom, the answer is going to be less than 1. So here, what number is greater, 47 or 3?
47.
Yeah.
Sorry.
So, no, you're good. So is 47 over 3 going to be greater than or less than 1?
Is 47 going to be, it's going to be greater.
47 over 3 is going to be greater than 1. Now, if we look back at the last page where we were looking at, 3 over 47. Is 3 over 47 going to be greater than or less than 1?
I mean, I know the answer, but I want to really understand it. I don't think I understand this part. So, like, is the 3 gonna be greater? Oh, because it's smaller. The 3 is smaller than. Is that why? So,
Yeah. So, in
would that
fact,
mean I would be getting like a, that deep remainder number and all that?
so I think that yeah, like yes, there would be a remainder for sure, but beyond that, I think that just forgetting about the other number for a sec, and I may have complicated it a little bit by working with two numbers that are the inverse of each other, but let's just stick with 47 as a denominator for a second.
Okay.
You understand 47 over 47 would equal what?
1.
Yeah, because
Yeah.
anything over itself is 1. So
Right.
then 40, let's say 49 over 47. Would this be greater than or less than 1?
Less than.
So because 49 is greater than 47, that means that this is going to be a little bit more than 1. So because 49 is 47 plus 2,
Right.
this is basically the same as
So
47
it's
over 47.
okay. So it would be one and what point
It would be
two?
1 and 2 47s. So
Okay.
also, because 47 over 47 is equal to 1, this would be 1
One remainder 2.
47s.
Oh, I thought you were going to say one remainder 2.
Actually, it could be expressed that way too.
Oh,
That is,
okay. I was going to say because it would be one whole remainder the 2. Okay.
no, yeah. Yeah, that's perfect.
So if the number was okay, so if the number on top, oh my God, there's just one fly that I just want to die. Okay. If the number on top it was 46, then it would be like, yeah, basically
It would be like 0.9 something.
nine,
It
not
would be
something.
very,
Okay,
yeah.
okay.
Mhm.
Ooh, okay. I feel like that's feeling better in my system.
That making some more
Okay,
sense?
so yeah, I just have to remember the whole. I have to remember the whole factor, like the whole the whole whole. I have to remember if it's a whole or if it's less than a whole.
Mm-hmm. And sometimes when you are solving,
Or
like, say that you see a fraction and you're asked to express it as a decimal, so you're dividing it out, you can kind of think in your head by rounding. If you can see that 47, if you're working with 47 over 3, you know that that's going to be at least a whole number. It will be greater than 1 because 47 is so much greater than 3. So then if you were to do it, solve it out and find something that's point zero something, then you just do a mental check to realize that you got to go back and fix something. But
yeah,
that's why I do think it'll be good sometimes, even if we're bouncing around a little bit, to just kind of maybe have a little crash course, a little refresher about
yeah,
something that is
totally,
good to understand.
totally. My brain needs it. I
So
need
does
to.
that kind of make sense? Like looking at a couple of
Yeah,
different, so 3 over 47, because 3 is less than 47, this fraction would be less than 1.
right,
47 over 47 is equal to 1, whereas 49 over 47 is going to be greater than 1. It'll be
right.
equal to 1 and 2/47. Is that all
Yeah,
kind of
yeah,
clicking so far?
yeah.
All right, so now, do we want to look at, I feel like I
Oh
want to
my
come up
God, I
with
killed the fly. I think. Wow,
You're what?
ADD. Okay,
Oh, the
nothing.
fly.
Yeah.
I feel like I want to
Sorry.
come up with new numbers because I think I made that a little confusing with
Okay,
working with the
yeah.
same numbers in
I'll
different parts. So let's think.
scratch that
Let's
out.
do.
Bam. I'm not even gonna look at it.
All right.
I'm
How
done
about
with 3 and 47ths. 3
let's do.
47ths.
Would you like to do a number that has a remainder or a number with no remainder?
With one, because I think that's harder, right?
A little bit, yeah. So why don't we do 67 divided by 4? All right. So
Okay.
if we're going to solve this out using long division, we're going to
Mm-hmm.
write it as 67 divided by 4. Now, can you tell me what we would do first?
4 goes into 6. How
Yeah,
many
how many
times?
times?
I was doing your job. Just kidding. Okay. 4 goes into 6 one time.
One time.
1
What do we do
times
with that
4
one?
is 4.
Good.
Oh, I put the 1 on the top above the 6.
Mm-hmm.
Then I put the 4 down below the 6. And then I subtract 4 from 6, which is 2.
Very good.
Then I do 4 times 2. Shit,
Pause.
no, wrong. I dropped the 7.
There you go.
I need to remember that or it'll mess up my whole problem. Okay.
It'll come to you.
Okay, and then 4 times 27. No, 4 goes into, right?
Yeah, how many times does 4 go into 27?
27, 4, 8, 12, 16, 20, 24, and so 6 times.
Very good.
I didn't see you were doing the fingers.
Yeah.
Okay, 6 times. So then I put the 6 above the 7,
Correct.
and then I go 4 times 6 is 24.
Mm-hmm.
Then I put that below, and then I subtract 7 minus 4
Mm-hmm.
is 3, and then 0. And then, and then is that all?
So, do we have
16
the
remainder 3.
Yeah. And another way that we can express that, of course, we talked about how we can continue the problem. So this could be written as 16 remainder 3. It could also just be written as 16 and 3/4 by putting the remainder over the dividend. Does that make sense?
Putting the remainder over the dividend.
Meaning 16 and 3 over 4. I'm just showing you one other way that we can express our final answer there, but you got
Okay.
it. You got the answer. I don't
Okay,
think
but wait, so I can also, on the problem, like I'm
Mhm.
writing it up here,
Yeah,
I can put 6 remainder 3, or I can put 16.3, or no.
not 0.3. If you want to use
Okay.
a decimal, so I did show you
Yeah.
how we can do it with a fraction. If you want to use a decimal, if I were working with pencil, I would erase that, but it's all good. What would we put after the 7 if we want to continue the problem here?
0.
Before we put the 0, there's one other thing we have to put.
Oh, a point. A
Yes.
dot. Yes.
The decimal point. And when we put the decimal in our divisor right here, we're also going to put it up here in our
Above.
quotient.
Uh-huh.
That's right. Now, what do we do with that 0?
Drop it like it's hot.
Very good.
And then we can keep going and going and going.
We can keep going and going and going.
Are we going to keep going or no? You were just showing me, right? Or
It'll look a little sloppy on my page, but we can still talk through it. Why not? How many times does 4 go into 30?
oh wait, hold on. I'm now updating my paper. So I can't wait. So sorry. Can we go back before we finish this? Can I put 6? So when I have it written out like this,
Mhm.
then I can put the R, right? The remainder.
Yeah, it really kind of depends on how you're being asked to solve it. So typically,
Okay.
when you're first learning long division, some teachers might ask you to just go ahead and write R for whatever the remainder is. As you get more advanced with long division, then you'll be more likely to be asked for a more precise answer, which could be expressed with a decimal and could be expressed with a fraction. So I showed you one way that we could express it as a fraction, and then last time we were also working on how to express it as a decimal. So did you already write R3 on there?
Yeah, but or
Okay,
R.
that's it.
I just put R.
Okay. No, that's cool.
But I'll just wait. We're gonna do. Are we gonna? Whoops! It's there. We go. Are we gonna finish doing the whole long? Are we gonna finish this? Four goes into
We,
30,
if,
and
if you already wrote R on there, you don't have to finish it on yours. You can just write R3 and have that be your answer. But I figure if it doesn't hurt to just talk
why
through
not?
what we would still do here.
Yeah. Okay.
So,
So 4 goes into 37 times, I believe.
correct. Very good.
But wait,
7.
what's the number? 4, 8, 12, 16. Oh, sorry, 20, 24, 28. So it's going to be remainder 2. But okay, so
there
it
are
goes.
still 2 left over. That's right. So 7 times 4. And if you don't want to write this on your page, if that'll make it sloppier, that's okay. 7
It's
times
okay.
4 is 28.
7
30
times
minus
4
20.
is 28, and then you minus, and it's 2.
That's correct. And then, because we do still have a remainder there, we're going to get a clean answer with just one more 0. So now I'll bring down one more 0, and that 2 becomes 20. Now, how many times does 4 go into 20?
4 times. Oh, sorry, 5 times. No,
5 times.
4. Yeah, it does.
5 times 4 is 20. 20 minus 20 is 0. And now we've got an answer that can be expressed a few different ways. 16.75 or 16 and 3/4. So just to come back really quick to what I was showing before, when we initially finished the problem going through the 7, before we started adding any decimals, our remainder right here was 3. So when we have a remainder there, it is correct to express the answer as 16 and the remainder over the dividend. So if it's 67 divided by 4 and we get 16 remainder 3, we can write 16 and 3 over 4. What I think I'll want to do is probably after we get off here, I might try and make a little cheat sheet that can show just a few different ways that you can express the answer, because it is complicated with division when you can put things as a fraction, a decimal, a remainder. I do understand that it's confusing there.
Yeah, it is. But I think the more I just do the problems and stuff, my brain will get more, it'll be not so hard, I guess.
You will get there. I believe in you. Do you want to do one more long division problem before we move on to a different type of problem?
Mm-hmm.
All right. This time, let's do 936 divided by 6.
This is hard. Okay.
So
Okay.
936
Divide by 6. So 6, 936. Okay.
And so I'll express that as 6 into 936.
Do you know what express means when, in terms of dogs or like animals, when a vet has to help a dog express itself?
No.
Just kidding.
What
Okay,
does it
never
mean?
mind. Nothing. I'll tell you later.
All right.
Every time you say express, I think of that. It's just funny. Okay, so 6 divided by.
Yeah, 930 divided by, excuse me, 936 divided by 6. Um, Now I'm looking at the chat. I think people are theorizing about what that means. I
When you express their glands.
got it.
Okay.
All right. So, what are we gonna do first here?
Yeah, Peter said you need to give me homework and a quiz. Whatever,
Multiplication
Peter, I'll be really good at it, okay? Just kidding. Okay, so 6 divided by 6. Yeah, I wrote it out as 6, 9.
into
Is that
936.
what you say? So you wouldn't say 6 divided by 936.
You wouldn't say 6 divided by 936 because this problem here is 936 divided by 6. You can also say 6 into
Goes into
936. Now,
okay.
I don't think you'll ever see the problem written that way. Like if you're taking a test, I don't think you'll ever see the words in the question say 6 into
Unless
900.
they're like describing a story or something. Like how many times did 6? Yeah, they would just say how many. Yeah, okay.
But just speaking in
That's
terms
good to
of
know
the way
though.
that people talk about it, that is how people will tend to say this. They'll say 6 into
Into
936.
900. Okay, so otherwise if I say it the other way it would be 936 divided by 6.
Correct.
Okay.
I do think it's helpful sometimes when I'm thinking in terms of long division. Like when I'm starting here, step one, I would think how many times does 6 go into 9? I think
Yeah.
I could also say there what's 9 divided by 6, but thinking how many times does 6 go into 9 as a whole number does just help me in those
General, yeah.
steps.
Yeah. Okay.
So,
Cool.
on that
So
note, how many
6
times
goes
does
into
6 go into
9. 6 goes into 9 one time.
9? One time, very good.
1 above. 1 times 6 is 6.
Correct.
Then I'm doing the subtraction.
Very good.
Not 6 minus from 9 is 3. Then 6 times 3.
No.
Shit, I don't keep dropping the 3,
It's okay. You'll get there.
right?
That is what we do. We'll drop the
Okay,
3.
okay, drop
I know
down
that
the
can be a tough
3.
one.
I wrote it out. I wrote the arrow, so now my brain will remember.
Nice.
Okay, so then 6 goes into, that's why I was confused about the multiplication. I was like, I'm not supposed to be multiplying here. Okay, 6 goes into 33. 6, 12, 18, 24, or right? Is that right? 24, yeah, so that's 4 already. 24, so 35, and then that's all. So 5,
5 is
so
correct.
30.
And yes, 5 times 6
5
is
goes
30.
above the 3. 6, sorry, what's that?
Zin, so you were right that 5 times 6 is 30.
Yeah,
So where do we write that?
5 times 6 is 30. Then I subtract 30. I put the 5 above the 3, and I subtract I subtract 30 from 33, so that's 3. Then, Laura, bring it down, right?
Very good.
Then I
That's right.
bring down the 6. So 6 goes into 36 5 times.
6
5,
goes
10,
into
15,
30
20.
5 times.
Oh, yeah, sorry, 6 times.
6 times. There you go.
Okay, so
And we'll check our answer. What's 6
I'll
times 6?
put this 6 up there. 6 times 6 is 36, and then that's 0.
Yep. So there's
So
no
we got a
limit.
clean number.
So we've got a
Oh, Michael, Michael, you can't cheat.
I did notice you got the answer real fast.
We got a math
You got there
G up
too.
in here. What's
Very
that?
good. I said you got there too. You got it.
Yeah. Okay, good. I did that one. I did that one pretty good. I still almost forgot to drop the 0. I mean, to drop the 1.
Still pretty solid. All right. And then thinking about some of the other, let me think of what we were looking at yesterday. because everything that we just did. Oh, you know what? Can I share a window on my screen really quick? And
Mm-hmm.
maybe we do a warm-up problem similar to this, but also kind of similar to what I was looking at originally. All right, I've got a few windows open, and I was thinking about which direction I wanted to go in, but let me see here.
No, Michael, writing the answer before I figure it out is cheating for me. No, not doing doing it in head. I want to be able to do it in my head like that, really fast. Okay, so you want to add this one? Yeah.
Yes. So, looking here, this is a converting fractions to decimals worksheet, and with the work that we've got on here, all of these values are just based on what you see there for numbers 1, 2, 3, 4, 5, and 6. Does it look like these fractions are going to be greater than 1 or less than 1?
Less than.
Very good. So, if we were to start here with number one we actually could likely do without having to divide it out. And that's because the fraction is over 100. Now, before I help you anymore, do you know how we would express number
Wait,
one
what did you
as a
mean the
decimal?
fraction is over 100?
No, meaning that 100 is the number that's on bottom. The way that I said that was a little confusing. The denominator is 100. Like the bottom number is 100 because it's 97 over 100.
Yeah. Oh,
So,
okay. Like, yeah. Like,
so if we were to write 97 over 100 as a decimal, how would we do that?
97 over 100 as a decimal.
Hmm.
Because 100 is the whole.
Yeah, we can, yeah. So 97, well, it's confusing. If, so 97, do you understand what the problem is? Sorry, I got a little bit tripped out there too. But do you understand what the question is asking?
Round your answers to 3 digits if needed.
So
Convert to
97
decimal.
over 100 is a part of a whole. It's not a whole number. It's a part of a whole that's being expressed as a fraction. But remember, we can express values as fractions or as decimals. So, do you want me to just kind of talk through this one and
Yeah.
see what makes some more sense?
Yeah.
So, 97 over 100. Anytime we have a fraction where the number on the bottom is 100, then we can express it, and I'll see if I can write big enough that this appears on your screen too. But 97 over 100 is going to be the same as 0.97 because 0.97 is equal to 97 hundredths. Because if you remember when we were talking about place value a little bit the other day, when we look at what's to the right of the decimal point, that first space to the right of the decimal point is the tenths place, and the second space to the right of the decimal point is the hundredths space. So
Yeah.
0.97 is the same thing as 97 hundredths. Now, you won't be able to convert it like this with all of the fractions that we see up here, but because this one has 100 in the denominator, we're able to do that here. Now remember, 97 over 100 is the same thing as 97 divided by 100, or 100 into 97. So if we were to do a long division problem of 100 into 97, that's asking how many times does 100 go into 97? Well, it goes in 0.97 times. And that's the answer that we would get if we were to just 100 into 97. 100 doesn't go into 9. 100, or excuse me, it doesn't go into 97. So we would need to add a decimal. 100 goes into 970 9 times. 9 times 100 is 900. 970 minus 900 is 70. Then if we bring down another 0, 100 goes into 700. 7 times 100, 700. And so there we've got the same answer. We've got 0.97. But because 100 is already in our denominator, we can figure out that the answer in decimal form is 0.97 without even having to do the problem. I feel like I did just kind of talk a lot and go through some steps pretty quick. Did you
No,
follow that?
yeah.
Or
Yeah,
is
I
it
think so.
all
Yeah,
right?
I think so because it's part of, it's not a whole, right? You're saying the 100, that's what at the very beginning I was saying 97 and 97, I'm looking at it like 97 is the 100 is the whole.
That
So
is
it's less
I see
than a
what you're saying.
whole.
Yeah, yeah. That
So it
makes
would
sense. I think
be,
I might have not understood what you meant there, but now I get that. That makes sense. That's definitely a way to understand it. And I mean that's part of the thing with some areas of math is that like there's multiple ways to understand certain types of problems. So different people might solve things differently in their brain, but there's multiple ways to think about certain problems and still get the right answer. So I think it sounds like you are getting it, even if we're sometimes maybe just thinking through in different ways.
yeah.
We're getting there. But yes, you're right. So we've got
Okay.
the answer to number 1. Do we want to talk through number 2 now?
Yeah.
So number 2, 9 over 24. Let me come to a new page. I'm like writing huge on every page so that they can show up in the window, but that's all good. All right, 9 over 24. Now, how are we going to determine what 9 over 24 is equal to in decimal form?
Dividing
Yes. Dividing what by what?
uh 9 into 24.
Swap
I mean,
it. Because it's 9 divided by 24. If we want to use that language of into, then this is going to be either 9 divided by 24 or 24 into 9. You following? Is it just
so
still a little tricky to keep track of which?
no. Yeah, kind of, but I think I'm learning. So the number inside the box is always the amount you're wanting to divide. Did you already tell me that?
The amount you're wanting to divide. So this is when it can help to know which one is divisor and which one is dividend. Yeah, I feel like the chat might be getting a little confused too. I'm sorry, Ganja girl. I'm doing my best here.
No, you're doing good. It's fine.
So 9 divided by 24, 9 over 24. If we're going to write it in terms of long division, then 9, the number on top, the divisor, is going to be the number that's on the inside of our division box.
Okay, inside the division box. Okay, the
Yeah.
number on top, when it's written like that, if I need to divide it down, the number on top always goes inside the division, inside the box.
And thinking back to what I was saying about when it's expressed as a fraction, because 9 is less than 24, is 9/24 going to be greater than 1 or less than 1?
9/24
Yes.
is going to be, I'm thinking less than 1 because 24 is not 100, and we
Yes.
just did that problem.
So it is going to be less than 1. So that's why it makes sense here that how many times does 24 go into 9? Well, 0. And then we're going to have to go to a decimal.
Find the
because,
answer, yeah.
Because
Okay, so these are all your, yeah, I remember at the beginning you said, okay, I think I just got confused on the first one because it's already 100, but it's also probably one of the easier problems because you don't.
I say so, yeah.
Yeah. Okay, so let me try this. 24 divided by 9.
24 into 9.
Into 9. Shit. Okay, so I put 24, I put 9 in the inside box.
Yes.
And 24 outside.
Yeah. And if you
That's crazy. Wait, so have we ever done a number that was bigger? Have we ever done this with a bigger number?
Yeah, because yesterday, if you remember, or not yesterday, 2 days ago, when we were talking about, trying to remember which page it was on, when we were using 4 over 7, and we were asked to express 4/7 as a
Yeah, no,
decimal.
I mean,
And
sorry, not a bigger number, but a double digit. I've never divided a double digit like this with a smaller amount. I mean, with a
oh, I see
smaller.
what you're saying.
I've
Yeah,
never
so I
done
guess,
two numbers.
yeah, so this will be a little bit of a first in that sense, but we can get there. I think we can talk through it. You up for the challenge?
Yes.
Sounds good. All right. Did I lose my page? One sec. Here we go. So, does 24 go into 9?
No.
No, it does not. So we're going to put a 0 right here.
Okay. 0 above the 9.
Mm-hmm.
Okay.
And we had kind of talked about this yesterday. You don't need to go through the whole process of 0 times 24 is 0, 9 minus 0, because we're just going to end up working with the same number either way. What we can do, though, we'll put our point. What's the point called again?
Decimal.
Decimal, very good. And then what do I put after the decimal?
Another 0.
0, very good. So now, how
I
many
just feel
times?
like how am I going to know to remember to do that? Putting a 0 after. Like how I feel like I would just freeze up on the problem. Like, what do I do next? And then it's like, oh, just add a 0. Like, I feel like I'm just like I'm making up a 0 just to like see if the problem will work. I don't know. Anyways, okay.
Well,
It
with what the
feels weird.
problem is asking us to do, rounding our answer to 3 digits, we're converting to decimals, so we know that we're expecting to get an answer that has a decimal in it. So with where we are, remember, anytime you add a 0 after a decimal, it doesn't change the value. Just the same as if you have a 0 before a number that's before the decimal point. Remember how we were talking the other day about how like 3 is equal to 0, 3 is equal to 0, 0, 3? Like
Yeah.
having
Yeah.
a bunch of extra zeros before a number isn't necessary, but it also doesn't change the value. The same
Okay.
thing can be said of putting a 0 after a decimal point, because 3 is the same as 3.0, is also the same as 3.00.
So why is love here saying how many 24s go into 90?
Well, that's the step we're on. So
Right.
now, because now that we put a 0 there, now our next step is how many times does 24 go into 90? And I
Oh,
know
I
what you were
see.
saying, that these are bigger. This is a bigger number in the dividend now, so it will be a little bit harder, I guess you could say, to count by 24s. But I can do it with you here. So 24. How many? I mean, there's 24 hours in a day. How many hours is 2 days?
Yeah, 48.
48. And then 48 plus 24 is
48 plus 24 is 8, 9, 10, 11, 12, 2, 4, 5, 6, 7, 72.
72. Very good. And then 72 plus 24 is going to go over 90. So
Mm-hmm.
3 is the number that we're going to now write
Yeah.
in our quotient. And then 3 times 24, you just solved it. What'd you
Wait,
get?
where did you? Oh, you put the 3.
It's
Oh, I
above
put
the
the
0.
0 in the wrong spot.
Oh, did you? Do
Oops,
you
I
want
added
to pull
0 and
the Do you
I
want to
put it
pull my shared screen down so that the paper can be bigger?
there.
There you go.
Okay, so 90. Okay, so 24 times 9 was, oh, sorry, 24 goes into 90 5 times. No, 4 times and change. 3 times?
It's 3. Yeah, so we just found that
2, 4,
24.
6, 8, 9. I see. Okay. So, yeah, so it goes in 3 times.
Now, you just found out what 3 times 24 is. How many hours are in 3 days?
72.
72. So, 3 times 24 is 72. 72 will get written here. below the 90. And then what's 90 minus 72?
That would be 2. That would be 12.
Not quite.
Oh,
So,
sorry. I did it backwards. I was trying to do head math,
you're good,
subtraction.
you're good.
Okay. 18.
18, very good. And then, what are we going to add?
We're going to add a 0.
Very good. That 0 will come down. And now we've got a big number to work with when we figure out how many times does 24 go into 180. So, personally, one thing that I would kind of do in my head, rather than counting by 24s all the way up to 180, we already figured out that 180 times, excuse me, we already figured out that 24 times 3 is 72. So the next thing I would probably do is try and figure out in my head what is 72 doubled, because then that'll give me 6 24s. So 72 times 2 is going to be 144. So that's 6 24s. Are you following?
Yeah.
Okay. So 144 plus 24 is going to be 168.
Oh, I thought you were doing it. Okay, so
No,
wait.
yeah. I was sort of, if you wanted to jump in, you could have, but no, that's cool. That's cool.
Okay, so 20.
And
Wait, so
168 is as far as we can go without going over.
right.
So, do you catch how many we ended up with?
5. Oh, 6. 7.
7. Yeah.
7. Okay, so 7. So 24 goes into 187 times.
Mm-hmm.
And so we put the 7 above the 0. Right?
And then we
Oh,
do
good.
7
Yeah.
times 24, which we did just figure out is going to be 168. Now,
Yeah.
if I were doing this and wanted to just do the multiplication out and show my work, I would sometimes just think of that as 7 times 4 is 28. I'll put the 8 here, 2 up here. 7 times 2 is 14, plus 2 is 6. That's just kind of me thinking about multiplication out loud, because sometimes 7 times 24 is just a big number for me to multiply in my head. So just writing out the work of multiplying in the ones place and then multiplying in the tens place, it can help me a little bit, but we had already counted and gotten to 168, so that's actually okay.
Okay.
Are you following? Am I
Yeah. Yeah, no, I was just wondering. I was just hearing how you do it. I just did 24 times 7. Like I just wrote it out.
There you go. No, yeah.
And then I was going to do the math. I was going to do 4 times 7
is 28.
You know? Yeah, 28. And then, actually, I want to make sure I know how to do that right. Okay, hold on. 4 times
Do
7.
you want me to do that with you a little bit off to the side here?
Yeah, I'm just doing that. So I do 4 times 7 is 28, and I put the 2 above the 2.
Yeah. So you'll put
Then
the
I
8
do
on your answer
2.
and the 2 up here.
Yes, and then I do 2 times 7.
Yeah, there's 7
Is
times
14.
2, 14.
And then I add 2. 14,
Mhm.
15, 16. So 168. Okay, good. Just making sure I'm doing multiplication right.
That's right. That's right. No, yeah. I'll sometimes just basically do those same steps, but just keep it here, like within the long division problem. But yeah, no, that's good to be aware of. Just know how to do.
Okay,
So
and then now this one I know I'm going to have to cross out and make a 10. And so now I'm doing 2 and then 1 and then 0. So I have 12.
12 is correct. Very good. Now, I believe we'll just have one more to do, one more 0 to draw before we get a clean answer here. So, what do we need to write right here? I kind of
We
just said
need
it.
to add a 0 to
We'll
the
add
end
a 0.
of 9000. Then we drop that down to the 120.
Mm-hmm.
Then we do how many 24s go into 120?
Yeah, so we know that 3 24s is 72. What's 72 plus 24?
Sorry, what? You're ahead of you're
We can
doing
just,
it
we can just count by
your way. I'm doing it my way.
Okay, okay.
No, I mean like your way of doing it in your head, I haven't learned. So when
Gotcha.
you're doing, I'm still doing it how I do it in my way.
Okay. You want to just count by 24s?
Yeah, I would just do 20, or I would just do 2, 4, 6, 8, 10, and I would just know that 20 and 100, there's 5, and then that's kind of how I do it. I don't know if that's harder mentally, but that's how I can do it, so I don't have to. I don't
It
know.
helps to get there.
So
So, you want to start with
24.
the-
So 24 goes into 120. Oh, I guess, yeah, we would count by 24s. Okay, sorry.
No, you're good.
24 plus 24 is 48. Plus
Good.
24 is 52, 62, 72.
72,
Wait,
yeah.
hold on. Hold on. I need to really learn that. Okay, 24. I think, see, I have to learn. Maybe I need to do more cards or something. Obviously, I do, but I would literally write out 2, 24, 48, 48, 58, 68, 72.
72. That's 3.
And then 72 plus 24 again is 6. So 80, 96.
96. Very good. And then
And
96
then,
plus 24.
Jesus, my brain is suffering.
You can do this. You got this.
Okay, 96 plus 24 is 120. Perfect.
Very
120.
good. So how
Okay.
many was that?
1, 2, 3, 4, 5.
5. Very good. So we'd
Okay,
write that 5
so
up here.
5, and then
Now all we got to do to finish the long division problem would just be show our work. So 5 times 24 is 120. 120 minus...
wait. Why are you doing 5
Yes.
times 24?
Oh, just to finish the long division problem. Like once we write the number up here, then our next step is
Oh,
to...
duh. Okay, sorry. Okay, yeah, sorry. 120, and then we minus, and then that's 0. All 0.
Yep. So we don't need to write another 0 because we got a clean answer there. So
Okay.
9. So to bring it back to the original problem, and if you want to bring up the worksheet again so that we can look at that again, we could do that. 9 over 24 is going to be equal to 0.
0.37. I mean, 0.375.
Is correct. 0. Point. It's so hard.
Hi, Audit.
Hi, Audit LA. 3.
Hi, T.
T's in here.
Hi,
Hey,
Misfits.
in Australia. But good to see you
Giving
here.
me answers.
All right. So now, you want to do one more on this page and then maybe review something else?
Yeah, I think that was a little tough for me, so I should definitely do another one.
Sounds good. So before we even start solving this, looking at this, 1 over 21, do we think that that's going to be a higher decimal that's like close to 1, or do we think that's going to be a very, very small value?
It's a very small value.
Very small value. Very good. So if we, with this one, see a few zeros in our answer before we get to any numbers and zeros even after we put a decimal, that's to be expected based on the number that we're working with. So 1 over 21, I'm going to pull up a new page for this one. And then, do you want to pull the shared screen down again so that we can work on this and see the paper a little bit bigger?
Mm-hmm.
All right, 1 over 21. Remember, 1 over 21 is the same as 1 divided by 21. So if we're going to express this with along division bar, what number is going to go in here?
1. 1.
Good.
And 21 in the front. Yeah.
Yeah. So, how many times does 21 go into 1?
0.
0. So now what are we going to write next to the 1 right here?
A point. Decimal point.
Decimal point. That decimal point will also jump up so that it's also in our answer right here.
Yes.
And then what can we write next to the decimal point?
0.
0.
Yes.
Now, how many times does 21 go into 10?
0.
Yeah, the answer is still going to be 0. So we'll put a 0 up here. And then, again, we can add in another 0 right here. Now, how many times does 21 go into 100?
Wait. Sorry. Why did you put another 100? I mean, you just put a 0 because it doesn't go into 10, so we need to add another 0.
Yeah, and we
Okay.
could, if we wanted to, multiply it out and do 0 times 21 equals 0, 10 minus 0 is 10, and
Oh,
then
I
bring
see. And
down
then
the
it would
0.
lay it all out. Right.
But then
Right.
it would still just be 100 that we'd end up
Right.
working with, so
So
just
we're
saving
putting
us a step.
100. Yeah. Okay. So now 21 goes into 100 probably 4 times, a little less than 5.
Very good. You got
See,
that.
see how my brain works like that. I can, because I know how many
You know 20
twos are
times
in.
5 is 100.
Yeah.
Very good.
Okay, so it's a less than 5, but I still don't know the exact answer. But 21 times 4, right?
That's right. Mm-hmm.
21 times 4 is 2, 4, 6, 8, 84.
84. Very good.
Okay, so now I put. Okay, so we put it in the. Is it called the tenths position? I mean, the
So
tenths place.
the ones place is going to be
Ones, sorry.
this first right here.
Ones, and that's why. So I was right. Tenths.
Yeah. So the 8 will be in the tens
In the
place.
tenths, yeah. Because I wasn't sure if it went under the 1, but I was like, wait, no, it goes in the tenths. Okay.
No, yeah, good job.
Okay, so
now what's
80
100 minus 84.
84, so 15, 16
16. Very good.
minus. So then I put okay, then I need to add a 0.
Very good.
Then I need to drop the 0
Mm-hmm.
to the 160. Okay, 21 goes into 160. 2, 4, 6, 8, 10. So it's going to go in about 1, 2, 3, 4, 5, 6, 7 times.
Good. Awesome.
Okay. Yeah, I want to be really good at. I'm gonna get some multiplication flashcards, guys, and division cards and stuff. Okay. 20. Okay, so what did I say? 7 times 2, 4, 6. I mean 1, 2, 3, 4, 5, 6, 7. Okay, so 21 goes into 160 7 times. So I'm putting the. Oh yeah, sorry, you're ahead of me. Okay, 7 above the 0. Then I go 21 times 7 is.
Do you want to write
4,
it out?
6, 8, 10, 12, 14. I am 147.
147 is good.
Okay,
Very
so now
nice.
I write 147 and then I subtract.
Mm-hmm.
I make this a 10, 7, 8, 9, 10. That's 3. I minus that. That's 4 minus 5. That's 1. And then 1 minus. Okay, so 13.
13 is correct.
Then I drop another 0.
We'll do another 0, and I think we'll make this our last one. If it's not a clean number, then we'll stop and I'll show you what we'll do there. But we'll do one more 0.
Okay.
Bring it down.
Thank you. Love to see you learning and accomplishing goals. My goals. Okay. Great that Laura can replay the video too to practice. Exactly, Tina. I literally today somebody was like, are you taking notes? Have you been and I'm like, yes, like I have, you know, my little book here, but I'm also like, I
can go back
also
and
can
watch
go
these.
back any single time and literally get a breakdown from Mr. Harkey right here. So
That's
I'm
right.
really loving it. And like once we're all done with this, anybody can I'm gonna put all of our classes and stuff onto one long kind of
Like playlists.
um yeah, so that somebody can easily quickly get their GED. So I really appreciate you, Jacob.
Of course.
Okay,
Love these.
so where were we? Sorry.
All good. So now we want to see how many times does 21 go into 130.
And 30. Okay.
Mm-hmm.
Okay,
We
so
already know that it goes into
to 147.
147
Yeah, seven
7
times.
times.
So
So
a little
I would
bit
just kind of
less
work
would be
backwards from there.
6 times. Yeah.
Good.
So I'm just gonna do 21 goes into, so 21 times 6. One, 2, 3, 4, 5, 6 is 2, 4, 6, 8, 10. Would be 126.
Very good. That's correct.
Be good. And then that's 4.
That's 4. And then we're going to go ahead and
See
stop
how
here.
fast I am on the smaller numbers? I want to be fast like that on the big numbers or hard numbers or the odds,
Oh, yeah. Yeah,
the
you're getting
evens
there.
and the odds.
Now, looking at our answer here, right now we have 0.0476. Now, that's 4 numbers to the right of the decimal that we have right here. If we pull back up the shared screen,
Uh-huh.
then you'll see on there that the instructions say to round the answers to 3 digits if needed. Do you understand rounding?
Yeah, the closest to the closest tenths, hundredths, or one.
Yeah, so depending on what we're rounding to, if we're rounding to the nearest 10 or rounding to the nearest 100, we'll look at the place value to the right of whatever it is we're rounding to determine if we're rounding up or if we're rounding down. And so if we're rounding to 3 digits or to 3 digits after the decimal, then what that'll look like is if we've got 0.0476, because 6,
476.
yeah. Is that what you've got on your paper?
I have 47. Oh, I just didn't put my number up.
Oh, okay.
Wait, where did I get 6 from? Oh, times 6 stuff. Okay. Okay, so yeah. Sorry, go ahead.
So, because we're rounding to the nearest third digit, or excuse me, because we're rounding it to three digits, what we want to look at is after the decimal, we have 0.047, and then now, because that's still not done, we want to see if that 7 is going to round up to 8 or down to 7. So the number that's to the right of that 7 here, if it's 5 or above, then 7 is going to round up to 8. If it's below 5, like 4, 3, 2, 1, or 0, then our answer is going to stay 0.047. So, because we have a 6 right here, that means that we are going to round up. Did that make sense?
Because it's above 5.
Because it's above 5, yeah.
Yeah.
So the
So
way I'd write this is I would use that equals-ish sign, like that estimated or is about
mm-hmm.
0.048.
So we're making the one either bigger or less, whatever it's closest to. It's closer to the 10 in this. So we would change the 7 to 8 and it would be 0.480.
Yeah. Mm-hmm.
Okay, cool. So when they say round it to that, that's what they're talking about. Whether
Yeah.
it's the 1 or the 10, it's saying bring that number to, even if they said bring it to the closest hundredths, then it would be closer to 0.05, right?
Uh,
I mean,
yes, good. Yes,
point
correct.
zero five.
0.05. Yeah, if we were just
If
rounding
it
it to
rounding it to the
decimals,
nearest hundredths, right?
if we were rounding it to the nearest hundredth, then yeah, it would be 0.05 because
And
that's
if it was
7
to the
held that 4.
tenths, it would be 0.048 to the nearest tenth, right?
This would actually be confusing. If it were rounded to the nearest tenth, it would actually technically just be 0 because if we're rounding it to the nearest
No,
tenth,
I mean that number. I'm talking about the number, the actual number. Oh, sorry. Yeah, go ahead.
like if we're rounding it to the nearest tenth, so the tenths place would be this right here. So because we already have 0.0, we would look at the number that's to the right of that 0, and if it's 5 or above, then we'd have zero point 0.1, and if it's 4 or below, which it is, then we'd round down to 0.0. That's if they were asking us to round it to the nearest.
Oh, for the whole number, you mean? Yeah.
Yeah. That's not what they're asking us for here, but
Right.
that is what the answer would be if they were asking us to round to the nearest tenth.
Right. It would be 0.
Very
Point.
good.
It would just be 0.0 because it's not closer to 1.
Exactly.
Smart. Okay. Wow. So really, I know this sounds stupid, but like you could really just break down anything to the tiniest thing.
Mm-hmm. Oh yeah.
Like all the yeah.
Well, in some things, when there's not a remainder and we get an answer that terminates, then we don't need to round. But like for some of the answers that are on the sheet that we were looking at, some of them it says round to the nearest 3 decimals if necessary. Because for some of them, we get an answer quicker than that, and then we don't have to. Like for 97 over 100, we don't have to round that to the nearest 3 decimals because we get a clean answer with 0.97. So that's not even rounded, that's just exact.
Yes.
With a value like 1 over 21, that just doesn't come out cleanly. So that's one where it is necessary to round, and when we round, that's what we get. So now, do you want to switch over to look at a greatest common factor?
On this.
So
Oh wait,
actually,
greatest common factor. Okay, yeah. Yeah,
yeah.
yeah.
So if you
Like
want to
what we
pull
were
this
doing
down,
yesterday.
yeah. So I'm thinking now I can go ahead and share a different window. Let me pull up the one that I was looking at that has greatest common factor on
Significant
it.
digits. What's significant digits?
S-
1/20 is 5%, whereas 1/20 is slightly less than 5%.
Oh, I see. So he's saying that can be one way that some people will understand, like basically estimate and know that their answer is about right. So 1 over 20 is 5%. Like 1 over 20 is equal to 5%. Um, because 1 over 20 times 5 over 5 equals 5 over 100. So that's without getting too into the weeds, that's like another way. I feel like I say that all the time and then end up like going on a tangent in a different direction. But just to kind of talk through what Peter is saying there and how I'm understanding what he's saying that 1 over 20, he knows that's 5%. And you remember how I've been saying that if we multiply the top and the bottom of a fraction by the same number, that it doesn't change the value of the fraction. It just shows us a different way to express it.
Yeah.
So 1 over 20, 20 times 5 equals 100, right? It's not
Sorry,
just
I'm
that.
starting to get it, and then I read the second part of the question where when he says, whereas 1 over
1 over
20
21 is slightly
slightly
less than
less than
5%.
5.
He's correct. And go ahead and leave that on the screen because that might help us as we're talking through this here. So 1 over 20 times 5 over 5 equals, what's 1 times 5?
5,
5. And what's 20 times 5?
25.
20.
Oh,
20
sorry,
plus 5
20.
is 25. What's 20 times 5?
20. I was like, 420. That's not the correct answer. Oh, wait, it is. 4.
20. No, that would be 20 divided by 5.
Oh,
What's
sorry,
20 times 5?
20 times 5.
Yeah, yeah.
2, 4, 6, 8, 10, 100.
100. Yes. So remember,
Oh, I
like
see.
we
So
did,
so 5% is 1/20th.
Yeah.
Whereas one,
Whereas 1 over 21 is slightly less than 5%. And one other thing that might get a little bit confusing here,
right,
5%
because
is
it
the same
takes it
thing.
out a little bit of each pie. That's how I think.
Well, and 5% is the same thing as 0.05. So 0.05.
0.5, right.
Yeah.
And
Not
zero
point
point,
0.5.
right, that's
Point
half.
0.5 would be like 50 over 100.
Right,
Point
right,
0.05 is 5 over 100. And
right.
so this makes sense because 5 over 21, excuse me, 1 over 20 is equal to 0.05. So 1 over 21 is going to be a little bit smaller than 1 over 20. So it makes sense then that our answer is 0.048 because we know that it's going to be a little bit less than 0.05. So
Mm-hmm.
by thinking of significant digits, that basically means if you can think of numbers that are a little bit cleaner that you know that are close to the number that you're working with, it can help you to estimate. So Peter did that with 1 over 21 because he knows that 1 over 21 is going to be a little bit less than 0.05. Did that thinking kind of make sense to talk through?
Yeah.
I know it's a lot. We're talking about like a lot of different ways to express some of the same values.
So can we do the math for 121? So I could just, can I do that just so I could see what the percentage would be?
Yeah, so that's what we did right here. When we did 1 over 1 divided by 21, and then we solved and
Oh,
got point zero four. This is it.
so that would be okay. And then we're rounding it to 0.480. I see, I see,
Yeah.
I see. So
Mhm.
yeah, it is going to be slightly less, even though the number looks like it would be more because it's 21. It looks like, right.
Yeah,
Is
so
that,
that's what
am I
happens
getting it?
when the denominator gets bigger. And there's actually a funny story about McDonald's that's related to this, but when the number on the bottom of the fraction gets bigger, the value gets smaller. And
Okay.
so if we were to just look at, for example, at 1/2, 1/3, and 1/4. These
It's
denominators
actually
are getting progressively
smaller.
bigger, but if
Yeah.
we think of putting a pi next to each one,
Yeah. Exactly. It would be taking up
a
more
half a
people take up
pi,
more pie.
yeah, a half a pi is this, a
Yeah.
third of a pi
Is one. Yeah.
is
Something like
this,
that.
which is smaller than a half, and then a
Yeah.
quarter of a pi
Is that.
is this,
Yeah.
which is even smaller than a third. So as because basically if you're thinking of it as parts and a whole again, the fewer number of parts, the bigger each part will be. If you're only cutting it into two parts, that means each part is going to be much bigger than if you cut it into four parts, then each part is going to be smaller. And if we were to keep going and eventually get to 1/20th, 20 is obviously a much bigger number, but if we cut a pie into 20 pieces, that means that each piece is going to be really, really small.
Yeah.
You understand that?
Yeah. Yeah. Yeah.
So, I don't even know for sure if this is true, but I've heard a handful of times that the quarter pounder with cheese is a very popular burger at McDonald's. And at some point, was this McDonald's or was it somewhere else? I heard when I was in school that that McDonald's temporarily introduced a third pounder, which a third pounder would be bigger than a quarter pounder, but it didn't do as well in sales. And when surveyed, people indicated that they weren't getting it because the quarter pounder is bigger, because the four is bigger than the three. But no,
Right.
one fourth
Yeah.
is
Oh, that's
actually
funny.
smaller than 1/3.
But visually, and I know they do that a lot with advertising where they'll be like, it's only 9.99, or where they're like it's just $1, or where they're like it's $100. It sounds like a lot more. Where
Or
nine
just
ninety nine.
4 easy payments of
Of,
29.99.
yeah, yeah, exactly. They lower the amount so it doesn't seem as big. I guess
Hmm.
9.99 is still a big number, but for some reason, I don't know. Does 9.99 sound smaller than $10? Sounds bigger. So maybe they are getting it wrong. They're doing their advertising wrong. Clearly, with
So
this
you asked.
McDonald thing, they're like, we're trying to give you a bigger burger. And they're like, nope, that's America for you right there.
Yep.
That's
You
funny.
know what they call a quarter pounder with cheese in France?
A Royale with cheese.
That's right. It's one of my favorite movies.
I love Pulp
I'm
Fiction.
glad you got that.
Scientology can't steal that from me, motherfuckers. Or John Travolta, even though.
That's right. That's right. It does have a. Actually, he's been in a couple of movies I love. I love Grease too. Grease is such a fun one.
Love Grease.
All right. I'm actually glad that we talked through that.
A Royale with cheese.
Is that kind of that too? But no, I'm glad that we talked through understanding.
Yeah. So
and
that helped my whole not getting the into dividing into something, and then also just like realizing that a number can look bigger, but it could be smaller. It could be of smaller value, just like you were saying.
Yeah, as
Very
that
cool.
denominator gets bigger, the numerator is staying the same. Then even if the denominator is getting bigger, that means that your value is going to get smaller. But I know it can be difficult to explain without a visual, but I think that particularly when looking at a half and shrinking down to a third, shrinking down to a fourth, that might help it to make a little bit more sense.
Yeah, exactly.
Right.
Hi, Ashley.
Hi, Ashley. Good to see you. Papusatology 99. And
Papusa!
California. All right, let me share my screen and share a new window really quick. This time,
Let me clear my throat.
let me clear my throat. Share screen. Just a sec. I pulled up a few windows. I want to make sure I'm grabbing the right one here. All right, let's look at this one. You see it coming up on your end?
This one?
Yes. So this one, this is not from the GED study guide, but this is from a greatest common factor worksheet that we worked on yesterday, and we did these 4 problems before we wrapped up, not yesterday, but 2 days ago, last time we streamed. We worked on these ones. So do you feel like you kind of remember
I
greatest
think
common
so.
factor? You want to review it a little bit?
Yeah, I think,
So-
yeah, let's do it.
So remember, when we're talking about factors, we're talking about numbers that can be multiplied together in a multiplication product to yield, multiplication problem to yield an answer, which in a multiplication problem, the answer is called the product. So before we look at a new problem, I think we can just quickly talk through some of the ones that we already did. So for number 1, what factors go into 7? It's going to be just 1 and 7. There's no
Yeah.
other whole numbers that can be multiplied to make 7.
Yeah.
For 28, there's 1 and 28 or 4 and 7. Now, the other factors that could go into 28 would be 2 and 14. We could also say 2 times 14 equals 28. But because we're trying to find the greatest common factor, that means what's the biggest number that can be multiplied to make both of these? So because 7 is the number, we know that 14 is not going to go into 7 as a whole number. So in this case, 7 is our greatest common factor.
Yeah.
Then for number 2, we did the same thing. 6 is made up of 1 and 6, or 2 and 3. And then 32 is made up of 1 and 32, or 2 and 16. The other ones that could go into 32 would be 4 and what? 4 times what equals 32?
4. 4 times 8.
Good. So 4 and 8 could also be written in here, but neither of those
It's
go
not
into
bigger
6.
than 6. Yeah.
It's not just that it's not bigger than 6. They're not.
I mean, it's not the common number, right? It's
Yeah.
not greatest common
Mm-hmm. Do you want to go ahead and pick it up at number 5 now?
Yeah.
All right. Let me get this in
Hi,
markup mode.
Foxy. Everybody say hi to Foxy.
Hi,
Come
Foxy.
here, Foxy. Boing, boing, boing,
Aw.
my baby. My baby. My favorite fox in the whole world.
Aw.
You do so good. You protect me while I do my schooling. That's very nice. It's very, very nice of you, my little angel. I love her so freaking much. I love you so freaking much. Foxy, do you know how much I love you? I love you so freaking much. Okay. Okay, so so the common numbers and so
Before we talk about
sorry.
the common factor, we'll first just want to look at the factors of each of these individual numbers. So if we're looking at number 5, let's think about what multiplication problems can bring us to 44.
4.
4 times.
Oh wait, 4.
That would be 1.
Okay, 4
Am I in drawing?
times.
One sec. I thought I was in drawing mode, but what do I press again? I'm still getting used to marking up the PDF. Here, I figured it out. Okay, so 4. What the heck? Why can't I see it? Oh, there it is. There was just a delay. My bad. All right, 4 and 4 times what?
11.
Good. 4 and 11. It's lagging so much more than it was the other day. And I don't know why the thickness of my of my pen.
Where are we going here, Mr. Harkey?
It started out when I started out writing, it was so thin, and then it got all thick right here. Do I have an eraser? Gosh, trying to write on the PDF is.
Oh, I bet you I can even zoom in and see.
Do you know what? Why don't
you can make it smaller? No, you can make it. You can go to the left side, right to your left. Click on that.
Is that a redaction?
And make it smaller. Redact. No.
Oh, that's not what I
go
meant
back.
to do.
Do not show this message again.
Okay, let's click.
If you click on the squiggle on your squiggle. Oh, normally it'll make it so you can make the oh, maybe the lines. You see the lines up there? Top right? Oh, sorry. Keep going to your right there. Those lines? Yeah. No. Down, yeah, there.
Shape style. Oh, okay.
See, you can make them not so thick. Right now it's thick like that.
What do I want?
See where it's checked? So you want to make it smaller, right?
So, gosh, that's so messy. Okay.
Let's see.
4 and 11. Gosh.
Yeah.
You get the idea.
And you can always undo whatever you last did.
Yeah, where do I do that?
There's that arrow that is like a roundabout arrow.
Yeah, I'm looking to see if I see that on here.
In your tools, maybe.
Edit. I don't even see an undo, add doodle, maybe.
Yeah, you can just do undo, and it'll undo all. Just keep doing undo, and it'll bring it back to 4.
Yep.
Yeah. See.
Well, my apologies to the chat for the delays on my end that are my fault.
I helped.
Thank you, Laura. Your help is much appreciated.
I'm a good teacher.
Yeah. I'll teach you math.
No, you're a great teacher.
I use my computer. Okay, so 4.
Hi, Maureen. Maureen.
More today than it was when we were working on this the other day. Yeah.
Yeah. Do you have other things open, maybe?
Not a lot.
Okay.
All right. Here, I think I'm gonna write it out a little bit more on here. So we're working with 44
Sandra's
and 30.
triple chin. Sorry.
We're getting there.
Side chat.
So
Okay.
44. We've got 4 and 11.
Yeah. 4 and 11.
Mm-hmm.
So what else? 8. Can 8 go in there? 8.
Not quite.
Nope.
8
Okay.
Not going to be a factor of 44.
2. We can do 2s.
We can do 2. Mm-hmm. How many times does 2 go into 44?
21 times. 22 times.
22 is correct. And then, of course, there's 1 in 44. We haven't done that yet.
Hi, Mark. Okay, so we did 4. So wait, 2. We did 2. Are you gonna you're marking 2?
On here, yeah. I'm not doing it on the PDF for right now, just because
Oh,
I'm
okay.
taking.
Okay, I'm gonna bring up your screen. Can we
That sounds
move
good.
that down? So we're just doing 44s and then 30s, right?
Yep.
I mean 44 and 30.
Yeah.
Okay,
So what are the factors that go into 30?
wait, so that was all the factors for 44? Or it doesn't
Yes.
matter, we'll just keep going. Oh, because it's above. No. Do we do eights? Yeah, we did
No.
fours, 11s, twos, 22 because yeah, it goes in twice. And then 44. And then okay.
I think this is it.
Okay. We'll see.
We'll see.
If no numbers come up on the 30, then I know I did something wrong.
We'll get there. We'll get there. All right. So 30. What are some multiplication problems that will help us yield 30?
5,
5 times what?
5 times 6.
Very good.
2 times 3. Sorry, 2 times 10. Tens.
You're getting there.
Wait.
So 2
What do you
times
mean?
10. 2 times 10 would be 20. Okay, so 2 and
Sorry,
10
2
do both go
times.
in.
Sorry. 2 times. Sorry, 3 times. So there would be 3. 3 times 10. So
Okay, so
10.
I'll write that 2. 3 and 10. But 2 does go in. How many times does 2 go in?
2 goes in 15 times.
Good. And the truth is, it's not super important necessarily for this problem that we get all of the factors down because we're just looking for the greatest common
Yeah,
factor.
the greatest common factor.
But I just figured it was good practice for us to get as many factors down as
And
we
we have 30.
Yeah, 1 and 30.
Yeah.
And
Okay, and then
I think this is all of them. So, what is the greatest common factor between both of these here?
2.
Good. So, greatest common factor.
Even though that's so low, it is the greatest one.
I know. Yeah, you would think that it would be something higher when the numbers are as big as 30 and 44. But yeah, the only common factor other than 1 is going to be 2. Well done.
All that work for nothing for a 2?
Do you want to do?
This is really cool. Like I really know how to spot common factors, greatest common factors, lowest common factors, multiple. Now I know how to multiply. I know I'm multiplying correctly and subtracting.
Long division.
Learning division, learning fractions, how to create fractions and how to convert them.
Very nice. So do you want, since I think we've been going for about an hour and a half now, do you want to look back at the study guide now that we've reviewed some of what we've gone over? Do you want to look at some new stuff?
Yeah.
All right, sounds good. So you can go ahead and pull down the one, currently shared.
Okay.
And then, let me see here.
Oh, whoops,
wait,
sorry.
no, sorry.
Yeah. But not this, right?
Yeah, so I'll stop sharing this. And then what I'll come to now. Bear with me.
Wait, Peter said use the GCF in a real life example. What's GCF?
That's greatest common factor.
Oh, duh. Ding.
So greatest common factor I find to be most applicable when you're reducing a fraction. So for example, if we receive the fraction, let me think. Let's say 16 over 36. If we receive the fraction 16 over 36 and we're asked to simplify the fraction, I'm just going to draw a line here so that we know this is a new problem. simplify the fraction, and then the fraction that we receive is 16 over 36. So that means that we want to reduce this fraction, the numbers that are in this fraction, so that the numbers are as small as they can be. Because I'm trying to make sure that I'm saying this in a way that makes sense. You know now that we can change the numbers that are in a fraction without changing the value of the fraction, because 1/2 is the same as 5/10, is the same as 10/20. They're
Yeah.
all the same value, they're just expressed different ways. So with those examples, 1/2, 5/10, 10/20, the simplified form of that fraction would be 1/2, because
Right.
1/2 can't be broken down anymore.
Right.
5/10 is not simplified because both 5 and 10 are divisible by 5. 10/20 is not simplified because both 10 and 20 are divisible by 10. 16 and 36 is not simplified, and in order to simplify it, we would want to figure out what is the greatest common factor between 16 and 36. So without doing the whole writing out all the factors, figuring out which one is biggest, can you think of a common factor between 16 and 36? Like a number that goes into both 16 and 36 evenly?
12. Oh, sorry. 16 and 36. 8.
8
Does it go
does go
8?
into 16, 8
Not
doesn't go into
36.
36.
Okay. 6. 6 plus 6 plus 6 is 18.
6 does go into 36, but 6 does not go into
Not
16.
into 16, yeah. Then just 2, I guess.
So 2 is actually not going to be the greatest
Or
common
3,
factor.
3, 3.
It's not 3. Let's stick with 2 for a sec. So 16, we're going to do divided by 2 over 2. And just the same as with multiplying, if we divide the top and the bottom by the same number, the value won't change. So now, what's 16 divided by 2?
Divided by 2, 8. 2, 4,
Yes.
6,
That's right.
10, 12, 14, 16, 18. Yeah.
Good. And what's 36 divided by 2?
Also, Peter said you get a cookie.
Thanks, Peter. What is
8.
36 divided by 2?
No, is it 36? I was thinking 16. Okay, and that's still okay. 36 divided by 2. 2, 4, 6, 8, 10, 12. Sorry, guys. 14, 16, 18, 20.
Oh, wait. Sorry. Never mind. Go ahead.
22, 20. Wait, now you confuse me. Why were you saying the Lord?
I'm sorry. I was thinking that you were. Do you want me to just talk through it for a second?
Yeah.
So, the answer, 36 divided by 2, it's going to be 18. And so I was thinking when you said 20 that you had gone too high. But then I think what you were doing actually was counting by
2, 4, 6, 8. Yeah.
Yeah. So then once I realized that, then I was kind of like, oh, wait, never mind. But that's okay. I mean, 36 divided by 2 is going to be 18, though. You would have gotten there if I hadn't thrown
Right.
you off.
Okay, so then
note that 8 over 18. So is 8 over 18 fully simplified, or could this still be simplified more? Is there still any common factors between 8 and 18?
8 and 18.
Mm-hmm.
Is there any common factors between 8 and 18?
Yes.
2.
2, exactly. So that means that we can just keep reducing. So we don't need to go back to the beginning and find a new greatest common factor. We can just keep reducing the fraction that we've got. So now 8 divided by 18, or excuse me, 8 over 18 divided by 2 over 2. What's 8 divided by 2?
4.
4,
Sorry,
good.
8, yeah, 2, 4, 6,
That's right.
8.
And then 18 divided by 2 is?
9.
9. Very good. So this would be the simplified fraction. 16 over 36 could simplify down to 4 over 9. So if we had originally divided by 4, 4 would be the greatest common factor between 16 and 36. Then we'd do 16 divided by 4 is 4, and 36 divided by 4 is 9. So just responding back to Peter's original question.
Sorry.
You. With Peter's question.
Excuse me.
Bless you. With
Thank
Peter's
you.
of what is a real world example of greatest common factor, this is when greatest common factor would most typically be used in my experience is if you receive a fraction or if you finish a problem and you end up with a fraction that is not simplified and you need to simplify, then you'll use greatest common factor to simplify the fraction by dividing the top and the bottom by the greatest common factor. Does that make sense?
Divided. Yeah.
Very nice.
It just seems hard, but yes, I do understand it. You can take any number, any size of something, and without ruining or breaking the whole of it, you can break it down by finding the greatest common factor
Mm-hmm.
and then
you'll still keep the same
dividing
value. So
and just to dividing those down, like cutting them, dividing them as small as they can get.
yeah, like as small as they can get while still maintaining the same value. Because 16 over 36 is
Right.
still the same. It's equal to 4 over 9.
Yeah.
So
So this is just a way to be able to say it or to write it.
Really, I was mainly just bringing this up as a way to show a real world use or show an application of greatest common factor. So now,
Okay, cool.
if I share my screen and then I pull up the one sec here, GED study guide math, do you want to bring this one on? Oh, where is it?
Very good.
Oh, there we go. All right, so let me see where we left off yesterday. So yesterday, that's right, we did this one related to least common multiple. Now this next one, this one is a little bit complicated. This one is about simplifying exponents. Are you familiar with exponents?
No.
So exponents are going to be these little numbers. If I zoom in a little bit, like have you ever heard somebody say 2 to the power of 6 or 2 to the power of 5? Or is that new to you?
That's the first time I've ever heard it in my life.
That's cool. No, that's cool.
2 to the power of 6. Woo! Sounds like a cheerleading song. We're gonna get 2 to the power of 6.
Woo!
Okay.
Now, have you ever heard somebody say squared, like 2 squared or 3 squared? Have you heard that before?
I think so, in like terms of measurements or something.
Okay, so yeah, because you've probably
Maybe.
heard of like square
Maybe.
inches
I don't
or
know.
square units.
Oh, yeah.
Yeah. So I'm just trying to think because the way that this question is framed, if you haven't really worked with exponents before, this is going to be complicated. So I'm thinking before we look at this, it might be a good idea to just take a step back and do a mini lesson on exponents. So actually, why don't you stop sharing the screen? And then if we just look here, exponents. So if we have 3 to the power of 2, a lot of the time when people, and that looks really small, I'm actually going to write that again bigger. We have 3 to the power of 2. What that means is we're going to have 3 times 3. Now, if we have 3 to the power of 3, that means we're going to have 3 times 3 times 3. So why don't we go ahead and solve these real quick. 3 squared.
9.
Yep.
Oh, sorry.
3 times 3 is going to be 9. Now let's come here. 3 cubed, or 3 to the power of 3. That's another thing. When we're working with exponents, anything to the power of 2, you can also say squared. So we could say 3 to the power of 2. We can also say 3 squared. But it equals 3 times 3.
Am I not getting what's the power of 2? I just don't understand why they say that or whatever.
That's just when we see this, when we see numbers expressed this way, where we see our main numbers and then we see another smaller number that's elevated up in the top right hand corner,
Yeah.
that just means 3, either 3 to the power of 2 or 3 to the second power, which means 3 times itself.
So would you say 3 to the third power?
For this one, yes.
Okay.
So here that's 3 times 3 times 3. So let's solve that out now. What's 3 times 3?
9.
9. I'm going to put 9 times 3. What's 9 times 3?
Oh, because you do 3 times 3 equals 9, and then you do times 3.
Yeah. Mm-hmm.
Okay. 9 times 3 is 21.
A little
Is
higher.
that right?
7 times 3
20.
is 21. 9 times
Oh, sorry.
3 is
9
higher.
times 18. 27.
27. Very good.
This
The
stuff is
3
my worst nightmare.
The 3 cubed is 27. So then, let me think. What's another example? Well, once you get into exponents that are above 3, like anything to the 4th power, then that's when you might start to need a calculator. But let's think. How about, why don't you help me solve 2 cubed, or 2 to the 3rd power?
Okay, so
So how else can that be written?
2 times 2 times 2.
Good. 2 times 2 times 2. Now, if we do 2 times 2, what is that?
4.
Good. So now we're left with 4 times 2.
8.
What's 4 times 2? 8. Very good. The 2 cubed equals 8.
Okay.
Now, what's a... I'm trying to think about how much I want to throw at you right here. But have you heard the term square root before?
I probably in one of my non-childhood school days. Yes.
So when you're asked about the square root of something, that basically means the opposite. Like what number times itself will equal the number that we're working with. So for example, if I were to ask what is the square root of 25, that can be expressed like this. So it's a box that looks sort of like the division box, except there's this little corner. Square root of 25. Can you think of what number times itself equals 25?
2. Oh, sorry. Times itself equals 25.
Yeah.
None.
What's 5 times 5?
Oh, sorry. I was thinking what number. You're asking me what number makes 25 when you multiply it?
By itself, yeah. So the answer is going to be...
I thought you said when you multiply 25 by itself. Hi,
No,
Foxy
sorry.
Lady.
I probably didn't
Hi,
make
my
it.
little Foxy Lady. What
And
are
we
you
are
doing?
going
Do you
through
want
a
to
lot
go
of fun
outside?
here. Oh, is Foxy getting antsy?
I don't know. Do you want to go outside? I can open the door for you if you want. You want to go outside? You want to go outside? Let me put you outside really quick. Oh, hold on. Sorry.
And then we'll be coming up on 2 hours in like 15 minutes. Do you wanna keep working for 15 minutes or so and then wrap it up, or do you wanna get out sooner?
Okay. Okay, so yeah, sorry, I heard the question in my head wrong.
No worries, no worries.
Okay,
Um,
so what by itself makes 25? Yeah. So, oh, I see.
the
So
square root
this,
of 25 equals 5 because 5 times 5 equals 25. So that means that the square root of 25 is 5. Now, for today, because we've already been going for a little while, the exponent problem that we have, I think, is actually going to be kind of confusing, and it'll probably be good if we start tomorrow, maybe with a little bit more review of exponents before we get into the question that's here. But if I look at the next couple of problems in the study guide, they're actually going to be a little bit easier. I think it would be good if we take a look at this next one. So the one that I was saying is up here. Exponents, they can get more complicated once we have 2 to the power of 9 times 3 to the power of 5 times 2 to the power of
wait,
4
hold
times
on.
3.
So
Like,
can we just try that first one? 2 to the power, it's so funny. 2 to the power of 9.
so this
Um,
one is going to be a little bit more confusing because the powers are so big and we're not actually going to be solving them out. We're just going to be simplifying them. I mean, to quickly just talk through how we would do this, the first thing that we would want to do here is this second set within parentheses has an exponent on the outside, whereas this first set does not have an exponent on the outside. So here we have 2 to the power of 4 times 3, and then that entire set is squared. When we have an exponent on the outside of parentheses and also an exponent on the inside of parentheses, we're going to multiply those together. So that would give us 2 to the power of 8 times 3. Uh, to actually keep solving this one out, I think I kind of have to write it out. So I'll write it out here, but then if you don't get this and this is like overload for today, well, I'll write it out. Maybe it will make sense. Let me write it out.
okay.
2 to the ninth times 3 to the fifth.
So are you going to write this out, right? And then I'm going
I'm
to
gonna write
remove
this
it
out.
so I can see your thing better.
Yes, times 2 to the fourth times 3 squared. All right. Yeah, you want to go ahead and remove my screen now? Yeah. All right. So 2 to the power of 9 times 3 to the power of 5. That's one set. And then this set here is going to be 2 to the power of 4 times 3. And then that whole set is going to be squared right here. Now, when we
What do you
have
mean by square?
to the power of 2, squared is just another way of saying to the second power. So since we've got a 2 right here, that means that this whole set, 2 to the fourth times 3, is going to be squared, or done to the second power. I'm trying to think of language to make it make sense, but it is tricky. So, but anyway, what I was saying, gosh, I'm trying to keep it concise without going through too many steps at once. Yes,
You
this
want to
this
read
is
what
where I was going
Peter
to go,
said?
Peter Anderson. Yeah, order of operations is another thing that you need to understand in order for this to make sense. So, I think what I'm going to do for a second is I'm going to hold this page, and I'm going to come now to a set of steps called PEMDAS. You probably does the word PEMDAS ring a bell?
No.
So PEMDAS is an acronym, PEMDAS. And it stands for parentheses, exponents, multiplication, division, addition, subtraction. So it
PEMDAS.
means when you receive a really long problem that has a lot of different steps, it has a lot of different operations, it has multiplication and division, addition, subtraction, parentheses, exponents, if it has all of those things in it, you can't just do the problems in any order because it's going to change the answer that you'll get. So this is the order that you want to do the steps in order to get the correct answer. And I'm actually going to rewrite it one more way. I'm going to write P, E, and then MD and AS. And the reason that I'm rewriting it this way is that even though this is the order that we originally wrote with multiplication before division and addition before subtraction, really multiplication and division can be looked at together and addition and subtraction can be looked at together, because you will still, when it comes to multiplication and division, you'll want to be working from left to right. So if there's a division problem that comes earlier from left to right than multiplication, you'll still want to do division first. It might be hard for that to make sense without looking at the example in front of us. But that's what order of operations means. So I want to think of just a simple example here to show you why we need this. So for example, if we're looking at this problem, if it's something like 5 plus 4 times 3. So there's two operations in this problem. 5 plus 4 times 3, there's two operations. It's addition and multiplication. Which step comes first in our order of operations? Addition or multiplication?
Addition.
Multiplication's here, addition's here.
Oh, sorry, I thought you were asking me. But okay, but it says you mean in terms of doing this problem specifically 5 plus 4 times 3?
Yeah. So
what would I start with first? I thought I would add 5 plus 4, that would make 9, and then 9 times 3.
So this is why we need order of operations. I'll show you what we get if we do that. But we don't want to do addition before multiplication. So I'll show you how we'll do this. We'll do multiplication first.
Okay.
And so what's 4 times 3?
Multiplication first. 4 times 3 is 12.
12. So simplifying this, we get 5 plus 12. And what is 5 plus 12?
Wow, 18, 17.
17. So this is the correct answer. So I'm even going to write up here, correct. Now I'm also going to write over here, wrong, so we can see what happens if we don't follow the order of operations. If we see 5 plus 4 times 3, if we just work from left to right, what's 5 plus 4? We would get 9. And then what's 9 times 3? We'd get 27. So we'll actually get a different answer if we do the order of operations. If we don't follow the order of operations and we do addition first, then it'll change the value of what we're multiplying, which will give us a completely different answer. So does it make a little bit more sense now after seeing that example, like why we need the order of operations?
Yeah.
Awesome.
So you always start with multiplication with what's the first one? Oh, parentheses.
The first one's parentheses. So I just wanted to look at a simple example that just had like two operations, so that we would know we do multiplication before we do addition.
So why wouldn't they do like? Why wouldn't they just do 4 times 3 plus 5? Why do they do it like that?
To keep us on our toes. I mean, sometimes they're not always, problems are just not always going to be expressed super cleanly. I mean, you could think of it the same as when they gave us all those values on the first problem that we were looking at, where some of them were fractions and some of them were decimals, and then we had to convert them all to the same unit so that we could compare them. I mean, you could say, well, why don't they just give them all to us in decimals so we don't have to do the conversions? It's like, well, that's part of what's on us. That's part of our responsibility.
But so always you multiply first?
Before addition and subtraction, yes.
Okay.
But if there's an exponent in there, so for example, one other thing, if we were to do, let's say it was 5 plus 4 times 3 squared, then even before we do the
You do the squared
multiplication,
first.
we'd have to do the squared first. So what is 3 squared? Or 3 to the second power?
3 times 3 is 9.
Good. So then that'll give us 5 plus 4 times 9. So what's our next step?
So then we do 4 times 9
Mm-hmm. And what's that?
is um is wow, why is my brain not working? 4 times 9 is 32.
So close.
36.
Yeah, there you go. So then 5 plus 36 is
41.
41. Very good. Now, before we return to that problem that we were working on, do you want to just do some more practice of problems like this, where you have to focus on the order of operations? Because I could probably find a worksheet with some more problems that are like this.
Yeah.
Just because I think that that exponent problem that we were looking at is going to be pretty complicated for right now, but I could probably find some good order of operations worksheets that can help us to just practice like what we just
Yeah.
learned. And
Okay,
then
I didn't know that. So multiplication, division, addition, subtraction. Melissa says, "My dear Aunt Sally." MDAS. My dear Aunt Sally.
Yeah, that's the mnemonic that they would often teach us to remember PEMDAS for parentheses, exponents, multiplication, division, addition, subtraction. They teach us, please excuse my dear Aunt Sally.
Oh, cute. Cute.
So
Kind of
now,
like a quick brown fox jumps over the lazy dog.
oh, is that a what is that?
It just has all the letters of the alphabet.
Oh, okay, I gotcha. Um, let me see which one is going to be a good one for us to work here. Let's try. Ooh. Ooh, this is a fun one, it looks like. I think it will be. I'm just pulling up some of these worksheets for the first time, just as we're figuring out which concepts are good for us to look at. Okay, so let me share this screen now. Give me just a sec here. Share screen. Just a sec. We're getting there.
Peter's reminding us we are at 2 hours.
Time check. All right.
He's Peter's like my student, my friend's student, where he's like, it's time for break, teacher. Okay. Oh, whoops, sorry. We still want to keep that one up, right?
Yeah.
Or is that?
Yes,
oh,
this
here
one.
we go. Okay.
Okay, so for this one, maybe I'll zoom in a little bit. So this is one. Ooh, that first one has some big numbers. Which one do I want to start with?
Let's
Number
just start
three.
with the big number. Oh, but it's minus.
I mean, there's a handful of different problems in here. I'm just thinking. I mean, we could do number one. You want to start with number one?
I feel like we didn't do any subtraction or addition ones, but if you think that will be fine, it won't be as hard for me.
Let me think. Well, I just
So
want to get
wait.
used to the
So number
practice.
one, yeah, to see where we start, where I would start and stuff.
Yeah. So number one, and maybe it might be easiest if I copy that down and then we stop sharing the screen so that we can see the numbers bigger. So one, that's going to be in parentheses 5 cubed minus 4, and then divided by 11. All right. Now, do you want to stop? Let's stop sharing, and then you can see a little bit bigger on my screen. So 5 cubed minus 4 divided by 11. So please excuse my dear Aunt Sally. What is the first thing that we'll look at here? Oh, you muted yourself.
Oops, sorry. Please excuse my dear Aunt Sally.
What does the P stand for?
Parentheses.
Good. Do we have parentheses in this problem?
Yes.
Yeah, so we're going to start by solving what is inside the parentheses.
Oh, I see. That's where the P is. Okay, so we start first with parentheses,
So
then
yeah, before we
with
worry
whatever.
about what's over
Yeah,
here,
we
first
wouldn't do
solve
the
what's inside the
divided
parentheses.
by 11. Okay, good.
So then within
Okay.
the parentheses, we'll continue following the steps. So there's no parentheses inside the parentheses. What does the E stand for? Please excuse that E stands for
Um, equatant. What was it called?
exponents.
Exponents.
Do we have an exponent in this problem?
Exponent. What's the exponent? Is the square thing, right?
That's the power, the little
Okay,
number.
the power to the square.
So we've got
Exponent.
5 to the power of 3. So that's going to be the first thing that we'll want to solve. And I'm going to kind of actually, how do I want to write this out? I'm going to make a bracket, and then that'll help us to just know
5 times 5
5
times
times
5.
5 times 5
Yeah.
minus 4. So first, now within this bracket, we're going to solve this. I'm still going to write out the divided by 11, but we're not going to get to that on this step. So what is 5 times 5?
5 times 5 is 25.
25, good. So now, let me do 25 times 5. I'm just writing it out one step at a time.
Yeah.
Divided by 11. So next up, what's 25 times 5?
250.
That
Oh,
would be
wait, sorry.
5 times 10.
125.
Good. So now, in our parentheses, you've got 125 minus 4, all divided by 11. So now just one more thing to do inside the parentheses. What is 125 minus 4?
121.
121. Last one, last step. What's 121 divided by 11?
11.
Yes.
Well, 11 is 111.
So 11 times 10.
Sorry, it's 110. And then, so 11.
So it's 11, yeah. So in other words, 11 squared is 121. Or the square root of 121 is 11. But that's our final answer here.
The square root, of 121 is 11. The square root.
That means, like if we were to ask, what's the square root of 121? That means what number times itself equals 121? And the answer is 11.
Oh, square, because a square has 4. Or no?
You know?
Did I just confuse myself? Like if you were doing like a square room or measuring out a room, you would want to know, how do I make each wall the same amount, same measurements?
Yeah. So like time, yeah, and I also think of like if we're finding the area of a square, like if you want to find out how many square units something takes up, you can just multiply one of the sides like by itself. So for example, if you have a square where each side is 4
Right, then 4 times 4 times 4
centimeters, then yeah, to figure out the area of the square, you would do 4 times 4, which equals 16 centimeters squared. So yeah, in that sense, that's why, if that helps you to understand why we associate the power of 2 with squaring a number, that could help.
So it has nothing to do with 4 walls.
4,
like a square.
I guess you can think of it that way. That's not how I tend to think of it, but I mean, I guess you can.
No, but it's not the same meaning. It's not the same definition, right?
Not exactly.
Okay. All right. Well, okay.
Do you want to do a couple more on the order of operations page, though, while we've got this up?
Sorry, allegedly said I have an Instagram that can explain this.
Oh yeah, if you have a good reel or infographic, feel
He
free
he
to
he
send it our
sends
way.
them to me. Yes.
Yeah, he sends stuff to me too.
Cool, cool.
I'm not always the best about responding in a timely manner, but I do my best. All right, so I'm gonna share this screen again. So when you want to pull it up, then we can look at which one we're gonna want to solve next. There's a couple that actually look like they could be some fun in here.
Square root of 121 equals 11.
This is correct.
Do I sound
Very well done.
smart?
You do. Yeah, adding the British accent often makes
Square root,
sound
the
smarter.
square root
Square root of 121
is
equals 11.
11.
Oh yeah, that's gonna really help you with your math.
This?
I was being sarcastic. You're good. You're an adult. We're probably almost...
Hey now, this is a child-friendly channel. I am vaping lavender.
Love it.
Okay.
Do you want to pull the...
Pemmidas parenthesis I literally sound like I'm like speaking ooga booga language. Parenthesis, exponents, multiplication, adding, subtracting. Okay. As this light, I'm learning the walls of the world. Okay.
You are learning. You're absorbing quite a bit.
Yeah, this is a lot. I hope like my brain's like, okay, don't lose this information.
So how do you feel right now? Do you want to do a couple more that are on the PEMDAS page we've got pulled up, or do you want to, or are you feeling like you want to get ready to take a break for today?
Let's do one more and then we'll take a break.
Okay.
Is that cool?
Good. Yeah.
Is that okay with you, class chat? Class chat? Chat class? The chat that is in the class.
Okay.
Yeah, let's do that.
Pull it up to the screen again. Yeah. Sweet. Okay, so we just did number 1. Number 2 doesn't have any exponents. Numbers 3 and 4 do. Number 4 has some exponents in the parentheses. You want to do number 4?
Yeah, let's do that.
All right, let's do it. So I'm going to copy it down on my page really quick. And then once I've got it copied down, then
remove it.
We're going to pull it down so that you can see my paper bigger. So let me go ahead and write in the parentheses 10 squared minus 3 squared, and parentheses times 6 minus 3 times 2. All right, now we can go ahead and stop sharing and looking at the problem. Parentheses, exponents, multiplication, division, addition, subtraction. What are we going to do first here?
So we're doing the ones in the parentheses.
Yes, we're going to solve what's in the parentheses. And then looking at what's in the parentheses.
We're going to do, we work from left to right, you said?
That's right. And
okay, so we'll do 10 square of 2. So 10 times 2, 10 times 10.
There you go. What's 10 times 10?
20.
That's
so then,
10 plus 10.
Sorry, 10 times 10 is 100.
Good.
And then we'll do 100. So then I would first do the other. What do you call that again? Square?
Or the other exponent. Yeah.
Exponent. So I would do the other exponent because it has the square.
We're still on the exponent step, so we haven't gotten into the other operations yet. So what is 3 squared?
3. Wait, which one? What's the number on it?
Oh, it's 2.
2. Sorry, my eyes were deceiving me. Okay. So 3 times 2. 3 times 3. 9.
Good.
So it would be 100 minus 9.
Good.
Which would be 90. Which would be 89.
You want to try one more time?
Sorry, would be 91.
91. Good.
Almost. I almost had it. Laura Megan Anderson. So then 91 times 6.
Yeah, 91 times 6. That'll be a bigger number. Well, before what's the next step? What are we going to do next?
Okay, so we did 3 times 2. Okay. And so then we do 91 times 6.
We'll do 91 times 6. Uh-huh. Can you do that in your head or you want to do that on the paper?
I can almost do it.
Yeah, on the paper.
I'm like, I can almost do it. Okay. 91. It's so bad. I need to learn to not do this. 1,
No,
2,
there's
3,
nothing
4,
wrong
5, 6.
Going our way.
Really? I thought this was not. I thought I was not allowed to do this at the range.
No, the
1,
way I
2,
said
3,
it,
4, 5, 6.
I didn't mean that. Like, you should be able to do this in your head.
Oh, whoops. Sorry. Okay, yeah.
You could.
18. See, then but I almost can do it. I just have to get better. Okay, 18, 18, and 18. That's what I'm going to do. And then,
Do you want me to show you how I'm doing this?
hold on.
How we can solve 91 times 6?
2, 3, 4, 5. It's 546.
Oh, awesome. Yeah, you got it. That's correct. 546.
I do want to know the way you do it, but I haven't. I only know this one way to do it in my head, and I don't want to learn a new way when I'm learning new stuff.
I get you. Yeah, one thing.
But I can learn that way later. I just want to learn this first one way, and then I can learn it other ways.
I get you. Makes sense. So,
But, yeah.
91 times 6, we've got that now as 546.
Yeah.
Any more multiplication in this problem?
So now we would do, hold on, 3 times, we did 3 times 3, which was 9. So that's where we got that. Okay. Sorry, I'm catching up on what we did. Okay. So now 91 times 6. And so the answer is 546. So then I'm assuming the next thing we would do would be 500 and we would leave that, and then would I do 3 times 2?
Good. What's
and
3
that
times
is
2?
9.
That would be 3 squared.
Sorry,
3
times 2 is 6.
Is 6.
I was getting too crazy.
You're good. All right, last step. 546 minus 6.
540.
540. Very good.
Wow.
Right.
Wow. So that 540 is the product.
Good.
Of the.
Well, product.
What would you call this whole thing?
Let me think.
The PEMMAD, whatever.
Yeah, it's an order of Well, let me actually think. It's a problem. I'm trying to think if there's a better. If there were variables, I would call it a polynomial. But when there's not variables, if there's no equal sign, well, and I guess there is an equal sign on the worksheet, we can call it an equation.
So when I would write it out like that, when I would answer the equation, I would write it with a box like that, 540, or you're just doing that to.
That's just a habit that I have from homework.
Okay, no, I like that.
We'd
just
have to box our answer.
Box the answer. No, I like that.
Sometimes they'd even have us highlight it just so that it was easier for the teacher to check our work and make sure that we showed our work and got the right answer and that she can find the answer easily. Yeah, mathematical problem, equation. There's multiple terms that you can use.
You're like, Kathy's like, just the simple fucking thing. Math problem. Oh, thank you, Tina. I am getting it, believe it or not. If Laura is getting all this, wow, super impressed. I really am getting it. I really am getting this.
Glad.
I understand. It's almost like a dance. Like first these go and then these fall in order. It looks like just a bunch of numbers, but if you do everything in order, it like kind of crochets out correctly.
Mhm.
If
That's
that
right.
makes kind of some sort of sense. But that's so. Can we do one more before we end? Is that
Yeah,
too much?
yeah. No, no, no. If
Sorry,
if you're
guys.
still if you're still on a roll, yeah, we can keep going. I
Let's
was thinking,
just do one more of these. We'll pull up one more of the problems on the
yes.
spreadsheet. Okay.
Let me.
How do
Uh,
you know if the question is an exponent? Would the question stipulate that? Wait, how do you know if the question is an exponent?
how
Would
do
the
you know if the
question,
question is an exponent? So if it's an exponent, that means it's that little tiny number that's. So I did just
because it's up above the number, right? It's up,
yeah.
it's letting you know, like, hey, nice try. You got to do something right here.
Yeah, if you wanna queue up my screen is queued up to share, and so if we
Oh,
wanna
sorry.
show it higher, yeah. So in just number one, that's right there on the screen, where you see 5 to the third power, because
Yeah,
that 3 is smaller than all the other numbers, and it's up in the top right-hand corner, we know that that's not just 53, it's 5 to the third power. If
right.
I
Which
think
means, and
I think
that's always multiplication, right?
it'll be, yeah, times, not times the number that's up there, but times itself that many times. So five to
Right,
the
right.
third power is five
Would
times
be
five.
5 times 5 times 5,
Yep, that's right.
not 5 times 3, which I almost did last time, which
It's
would
a
fuck up
common
my whole
mistake.
math.
All right.
Exponent is squared or cubed.
Or
Thank you,
even higher
Kathy.
ones, to the fourth, to the fifth. Yeah, so squared is to the second power, and then cubed is to the third power. And then if we're dealing with bigger exponents,
Wait. Sorry. Back up. I don't
yeah,
want to get lost.
no worries.
Exponent is squared or cubed. Um, wow, the third power thing is throwing me off. Okay, or to the, okay, so like number 4, it says 10 to the second power.
Hmm. So we could
Meaning,
say
and
that.
when you say power, when you say it that way, I'm thinking that it's 10 to the second means the number 2 has the power to multiply the 10.
Um,
That's kind of how I think of it. Like that has the power. That is the force. It's like the power given to the 10 is multiplied by 2. Is that wrong? Is that,
I mean,
I don't know.
if it helps you to think of it that way, that's okay. As long as you understand that 10 to the second power means 10 times 10. If it helps you to think of it the way that you said it,
Yeah,
I think that's
it
fine.
means like times this big number that I'm sitting on.
Yeah,
That's what I
that
think.
many
Okay,
times.
but so then the 2, let's say in the same number 3, or sorry,
Mhm.
any of them, number 4.
So yeah, we just did
The
number four.
3,
So yeah,
yeah, so the 3 and then the 2, the power to the 3, the 2, the power to the 3 is the 2 right there.
it says 3 to the power of 2. Yeah.
3 to the power of 2. Exactly. Like I have to, meaning, yeah, okay. In my mind, the 2 is giving the command or the call, like is telling you what to do with that 3.
Oh, okay. I see what you're saying. No, yeah,
Anyways,
that's definitely a way to understand it. I haven't necessarily heard it said that way before, but if thinking of it in those terms helps you to remember what you have to do, then that
but
works.
okay, and so in the 10 and the 3 in here, there are always, it's always multiplication when
I mean, if you
when
see an
it's written
exponent,
like
yeah,
that,
it's going to be the
when it's on the top right like that.
yes, yes.
Okay. I'm never dividing it by 10 or any of that. It's always multiplication.
Uh, correct, correct.
Okay.
Yeah.
Okay, cool. So that's, I thought I was going to get even fancier, and I'm like, oh, I have to guess if it's division or multiplication.
So you
Okay,
did
so
number
let's do
four.
number 4. Or sorry, which
We
one
just did
were we
number
going to do?
four.
We did number 4.
So interestingly, number three has all the same numbers in it, but there's no parentheses, which just would change the order slightly. Do
Right.
you want to look
Okay,
at number
let's
three?
no, let's do the one with the parentheses. Let's do,
No, no, no. We just did that one.
I see. And we already did number 1.
We did number 1, we did number 4. We haven't done 2 or 3. I
But
was
two
saying
doesn't have any power.
exponents. We could still do it. What do you want to
Wait,
do?
what would you say? Would you say it doesn't have any exponent? Number 2, when it doesn't have the power?
Correct. There are no exponents in number 2.
Exponent. I'm getting confused. What's the difference between an exponent and power? Exponent is the number.
Exponent is the number that
You're just saying there's no numbers, whether it's power or not. Like it's. Is there something else other than power that would be written up there like a number?
Like, is there anything else that would be written up here? Is what you're saying?
Like up,
Or is it
like
an
where the 2, where the power would be, or the 3. You know.
Well, there is like an implicit 1, like 67 is 67 to the power of 1 because it's just 67 one time. It's and then if it was 67 squared, if there was a 2 up here, then that would be 67 times 67. So if a number, you don't have to put a 1 if if I'm trying to think of make this make sense. Any number, when it's just a whole number that's by itself, it can be written with the number 1 in the exponent spot, which just means to the first power. But if it's to the first power, it's already simplified and you don't need to put the exponent there for it to be correct. So when I say there's no exponents in here, it's just all of these numbers are as they appear. So you could, if you wanted to be extra, say 67 to the first power minus 18 to the first power divided by 7 to the first power, but it's just not necessary. So
because the first power is of itself. It's
just what these numbers already are.
Exactly.
None of these numbers.
So number 2 would be times 2. I see. Okay. Just kidding. Okay, so let's do number 2, even though there's no powers. I guess whatever. Exponents, because it's numbers. Exponent. God,
So
exponent.
2.
I don't know why that is not clicking. Like exponent is neat. It's just like letting me know there's no number. When you're talking about exponent, does it mean is it specifically speaking of multiplication, or is it just exponent, just numbers in general?
Exponents is specifically referring to the little numbers that are up in the top right-hand corner.
Okay, perfect. Okay, that's what it's called. Okay, so so I would say problem number 2 has no exponents. Right. So
I just copied number 2 down. So if you want to, we can stop sharing my screen and then we'll look at it here. So in the parentheses, we have 67 minus 18 outside the end parentheses divided by 7 times 3. All right. So what step do we have to do?
Parentheses first.
Parentheses first. That's right. So inside the parentheses, we have 67 minus 18. What is 67 minus 18?
Let me do that. See, I should just know this off the bat. Don't criticize yourself, Laura. You're doing great. Okay, 67 minus 18. It's okay to write it out. Put 17, make this a 5. 17 minus 8 is... Wow, my brain. 8, 9, 10. Okay. Wow, 9. Took me that long to get a 9.
You're good.
Okay, 9, and then 5 minus 1, 4. Okay, 49.
49 is correct. Very good. All right, so now we've got 49.
So we do 49, and then what was it?
49 divided by 7 times 3. Now.
Hold on. So the next thing I would have to do, it said, what was the thing?
PEMDAS.
PEMDAS.
This is a problem because of the way that it's phrased right now, where what I was saying here is going to be relevant. So do you remember how I was saying that?
Right, that's what I'm saying. So multiplication
and addition subtraction is like one step. So
right.
Looking at the problem, division appears before multiplication. But because the division becomes first when we're going left to right, we're going to do the division before multiplication. Does that make sense?
Yeah, because we're starting from left to right, and the division is not in the parentheses.
Mm-hmm.
So it
Now,
would be the next thing after we've solved
yeah.
the product.
Now, the same
We've
thing is
gotten the
not the
product.
case. Addition and subtraction will always come after multiplication division. So if it were 49 minus 7 times 3, then we would do the multiplication first. We're doing the division first because division is in that same step as
First
multiplication.
as multiplication.
So, so what
Okay.
is it that we're going to do next right here?
Okay, so now we're going to um wait, so we got 49. So now we're going to divide 49. Okay, so now we need to multiply.
No,
Sorry,
you're
no,
right. You're right.
whoops. So, okay. Divide 49 by 7.
Yes. So how many times
Uh,
does 7 go into 49?
um, how many times does 7 go into 49?
Yes.
7 times 5 is 35. So 35, 36, 37, 38, 39, 40, 41, 42, 40, 42, and 49.
How many?
Okay, so 7 times.
7 times.
That's what I knew. I had it right. I wrote 7 times 7 on the paper. I wrote 7 times 7. I was
Yeah.
just thinking it was approximately 7 because I was like, wait, 7 times 7, I naturally know is 49.
You
I don't know
got it.
why. Okay, I was
In other
thinking
words,
49ers.
7 squared is 49.
7 squared is 49. Correct. 7 times 7.
Mm-hmm.
7 times, yeah. Okay, good.
All right.
Okay.
Now, what's left here?
Oh, so now where are we? Okay, so
Or
that
are
is
you writing down?
49. Oh, interesting. So 49 divided by 49. Sorry, excuse
Hmm.
me. So sorry, so sorry. Okay, 49 times, yeah, so we're writing 7.
And
And
then,
then 7 times 3.
yes.
Okay, that's 21.
Very good.
And then, yeah, 21 is the product.
That's the answer, yeah. Well done.
Okay, cool. Wow. I think I definitely need, please excuse my dear Aunt Sally.
Mm-hmm.
Laura, get it straight. Please excuse her. Okay, please excuse my dear Aunt Sally. Sally. Okay, amazing. How do we feel, Jacob? I feel really good about this. I feel like I definitely need to marinate it and then tomorrow get nervous again thinking I forgot it all and then come back.
No, yeah, I think I'd say we made some good progress today. I feel like it was a productive day.
Yeah, I can't believe I learned what that the quote the what is it
Exponents.
called? Exponent.
No,
I
yeah,
learned
we
what
covered like
exponents are.
several lessons worth of math today.
Yeah.
When I was in school, exponents would have been covered over the course of weeks, where we would have probably started with just squared, like just two things to the power of 2. Then we would have gotten into order of operations and all these more complicated equations. Like, this is after having done several homework assignments where, because typically when a math curriculum is broken over the course of an entire school year, each unit will have several days spent on it where each unit is broken into lessons. Each day there will be like an hour to an hour and a half math lesson. Then the kids go home and do homework on that lesson, and then they come back the next day and build on it. But I mean, the way that we're doing it, we're just cramming in tons of
Yeah.
content, like weeks and weeks worth of lessons into however many sessions this ends up taking.
Yeah,
But
yeah.
I mean, it's working out too because it's in a one-on-one setting, so we can talk through any confusion that comes up like as it happens.
Right.
So
Right.
yeah, I felt like we covered some good ground today. See, and
Yes.
Dungeon Girl says went from expressing fractions as decimals to now doing exponents and orders of operations. Yeah, you've come a long way. You're moving a lot.
That's a lot fast. Yeah,
You
I'm
know?
so excited. Like my yeah, like I said, I have like my little endorphins because I'm learning. Whereas before there was never a teacher to teach, like to really be there one on one, or to really, I mean, you have a classroom full of people who have probably a bunch of very normal, different chemical imbalances and all kinds of things. And for Scientology to always restrict and to not even let people have that while, like, oh, hey, he's a genius at this, but, give him some time on, struggles a little with math or whatever. Like, there was just never that close connection. And so kids were always just having to fend for themselves, really, and try to get through a math book just so they wouldn't get in trouble. It wasn't about really learning because we didn't understand why we needed this knowledge or this data other than quickly just learn, the whatever the ways of the world are. And then L. Ron Hubbard will really give us the facts. So it's just crazy. Yeah. So, yeah.
Well, and there's also the other things that just come to mind, like as you're saying that, are realities that not everybody learns the same way. Like I feel like from what I know about Scientology, everybody learns the same study tech, and you learn that there is
Right.
like this is the way to learn. And the reality is different people are gonna pick things up different ways. And we were looking at problems earlier, like when we were looking at division, that there's multiple ways that these can be solved, and different students are going to have different preferred methods of solving, but they all work. And
Yeah.
when it comes to how kids learn, some kids are very visual and they learn well if they have visual representation of what they're learning about. Some students are just very oral in that what they hear, they can learn best just by listening. And then some students are more tactile or kinesthetic, and they have to be actually doing the problem and writing it out in order for it to make that lasting connection. But
And
that
do
just means there
teachers
are
know about that kind of when they have people and students in their class? They already know ahead of time, like, the difficulties or maybe their needs, their special needs or whatever. You work with people like that a lot, right?
Yeah, so since I teach special education, that definitely
Thank
was
you,
a big
Sinead.
part of the curriculum for my credentialing programs, that we want to make sure that we're presenting content with what we call multiple modalities, meaning multiple means of expression, multiple means of representation, so that students have multiple ways that they can learn. And whatever concept it is that we're teaching, they encourage us to use what they call a universal design for learning, meaning that the content is being expressed in multiple means, visual, auditory, kinesthetic, so that students have multiple opportunities to pick it up, to kind of absorb the content. And because all of my students are special education, they all have what's called an IEP, or an individualized education program. And
Mm.
their individualized education program will lay out what their learning disability is that has qualified them for special education, and what accommodations will be most beneficial to them to support their learning. So when my students are in a general education setting, I'll communicate with their general ed teacher and make sure that they have a copy of the IEP, or at least the IEP at a glance, which, because the full IEP comes out to be like several pages, like often more than 20. But IEP at a glance is just a one-page summary that lays out what is their diagnosis or eligibility criteria for an IEP, what are their services, meaning how many minutes do I work with them each week. If they have speech therapy also, then that'll be laid out
Uh,
on the IEP at a glance also. And then it'll
cool.
also lay out what accommodations do they have access to. And maybe that's hundreds chart or multiplication table on math tests. Maybe it's access to a calculator for certain math problems on a math test. Maybe it's sentence frames that'll help them for writing assignments. So, like, we've worked really only on math so far for the work that we've been doing. But when it comes to writing, for students who struggle more with that, they might have an accommodation, which is access to a graphic organizer or a sentence frame, so that when it comes time to write a paragraph, they don't have to just write it from scratch by themselves. They'll have sentence frames that they can fill in. So if they have to write about what is their favorite movie and why, they might receive a graphic organizer that says, my favorite movie is blank. One reason that I like this movie is blank. Also, I like it when blank. And then that just is an accommodation that helps them to complete their writing assignments. So
It
without
just goes smoother. Yeah.
those are just some examples of how I would say teachers nowadays do come to understand different learning styles and how to work with different learning styles. And of course, I've only been teaching for this is going to be my 5th year that I'm going into
Oh, wow. You're
teachers
really good at it.
for my thank you for my coworkers who have been in it for a lot longer. I don't know that the universal design for learning and like multiple means of expression was necessarily pushed as much like decades ago, like when my parents were in school. I would say that in recent years there's been much more of a push to accommodate all types of learners.
That's really cool. Yeah, we definitely didn't have that. And that's just, yeah. Peter was saying that you do this with like 30 students sometimes in a classroom.
Yeah, 30. Well, the max as a special ed teacher that I can have on my caseload is 28 students. But yeah, in a general ed setting, or when I push into a general ed setting, there are often that many kids in the class. So I mean, I think that was more in response to what we were saying about we're going through so many lessons at once right here, which if I were trying to go through all of this content with a room of
Yeah.
4th graders,
Yeah,
that
yeah.
would be very hard. A lot of people would be very lost. But when we're just working one-on-one, I'm meeting you where you're at, it works. We
Which
can make
is
it work.
so great. And yeah, it's amazing. And it's so great because other people watching this in the future can literally watch this as if this was their one-on-one, you know, and they can
That's
see what you're writing. They can see what we're talking about. They can see me not understanding something and then seeing why, you know, like, so it's so awesome. I can't tell you. It's really cool. So
right.
tomorrow, Monday?
Yeah, I don't have anything planned so far. So yeah, you want to tentatively aim for 5:55 tomorrow,
I
same
think
time?
so. Yep,
All right.
5:55.
All right. Let's do it.
Cool. Thank you so much. This was so great. And I'm excited. I need to get cards, I need to get, I'm going to make some songs and jingles and get some multiplication flashcards, just things to get really mentally good at this. Just so it becomes not so heavy. It doesn't feel so like, whew, I got through that, like I want it to be easy, which is getting. So I'm so excited. I'm very excited. So thank you all. And thank you, Jacob, so much. I'll see you guys all tomorrow. Thank you, chat. Thank you, everybody, for Peter, everybody, allegedly, all y'all in here, just being so
Thanks to
awesome.
everybody
And
in the chat doing the work along with us and sometimes giving suggestions for things that I need to teach you. In fact, right when Peter was the one who suggested teach Laura about order of operations, because if we're going to talk about exponents and solving big problems with exponents, that's good to understand. And
for
we were kind of on the
sure,
same wavelength for a sec. I was like, yep, PEMDAS is what we need to jump into now.
PEMDAS, yes. Yes, thank you so much. And Ganja says, thank you so much for doing this with me. Thank you, for reals. This is so cool. All right, chats. Love you guys so much. And we'll see you guys tomorrow, as of right now, at 5:55 p.m. Learning and loving with all y'all.
That's right.
See you soon. Bye.
Woo!